I see Lagos, where the Academician is returned to his tailor shop, where the shoemaker is happy doing his job, and our programmers can code 247. I see Lagos, where our children can learn under more conducive atmosphere. I see Lagos, where everything is connected and the city shouts for joy because the light has come. I see Lagos, where the economy flourishes because of better electric supply, where the people are happy with their government, and government happy with the people. The Lagos State Government through Ministry of Energy and Mineral Resources is partnering a co-innovation center to facilitate meter design hackathon that will develop an affordable and smart metering system leveraging local talent. 7 million naira to be won by the winning teams. We are calling all Lagosians to come watch the hackathon live from Wednesday 16th to Friday 18th of September 2020 as we pick the final winning teams. Register via this link to be part of the event: www.lagossmartmeter.com/event/sponsors. I see Lagos, where electricity flows from Bariga to Badagry, and Agege melts into Victoria Island. I see Lagos, where the Academician is returned to his tailor shop, where the shoemaker is happy doing his job, and our programmers can code 247. I see Lagos, where our children can learn under more conducive atmosphere. I see Lagos, where everything is connected and the city shouts for joy because the light has come. I see Lagos, where the economy flourishes because of better electric supply, where the people are happy with their government, and government happy with the people. The Lagos State Government through Ministry of Energy and Mineral Resources is partnering a co-innovation center to facilitate meter design hackathon that will develop an affordable and smart metering system leveraging local talent. 7 million naira to be won by the winning teams. We are calling all Lagosians to come watch the hackathon live from Wednesday 16th to Friday 18th of September 2020 as we pick the final winning teams. Register via this link to be part of the event: www.lagossmartmeter.com/event/sponsors. I see Lagos, where electricity flows from Bariga to Badagry, and Agege melts into Victoria Island. I see Lagos, where the Academician is returned to his tailor shop, where the shoemaker is happy doing his job, and our programmers can code 247. I see Lagos, where our children can learn under more conducive atmosphere. I see Lagos, where everything is connected and the city shouts for joy because the light has come. I see Lagos, where the economy flourishes because of better electric supply, where the people are happy with their government, and government happy with the people. The Lagos State Government through Ministry of Energy and Mineral Resources is partnering a co-innovation center to facilitate meter design hackathon that will develop an affordable and smart metering system leveraging local talent. 7 million naira to be won by the winning teams. We are calling all Lagosians to come watch the hackathon live from Wednesday 16th to Friday 18th of September 2020 as we pick the final winning teams. Register via this link to be part of the event: www.lagossmartmeter.com/event/sponsors. I see Lagos, where electricity flows from Bariga to Badagry, and Agege melts into Victoria Island. I see Lagos, where the Academician is returned to his tailor shop, where the shoemaker is happy doing his job, and our programmers can code 247. I see Lagos, where our children can learn under more conducive atmosphere. I see Lagos, where everything is connected and the city shouts for joy because the light has come. I see Lagos, where the economy flourishes because of better electric supply, where the people are happy with their government and government happy with the people. The Lagos State Government through Ministry of Energy and Mineral Resources is partnering a co-innovation center to facilitate meter design hackathon that will develop an affordable and smart metering system leveraging local talent. 7 million naira to be won by the winning teams. We are calling all Lagosians to come watch the hackathon live from Wednesday 16th to Friday 18th of September 2020 as we pick the final winning teams. Register via this link to be part of the event: www.lagossmartmeter.com/event/sponsors. I see Lagos, where electricity flows from Bariga to Badagry and Agege melts into Victoria Island. I see Lagos, where the Okadaman is returned to his tailor shop, where the shoemaker is happy doing his job, and our programmers can code 247. I see Lagos, where our children can learn under more conducive atmosphere. I see Lagos, where everything is connected and the city shouts for joy because the light has come. I see Lagos, where the economy flourishes because of better electric supply, where the people are happy with their government and government happy with the people. The Lagos State Government through Ministry of Energy and Mineral Resources is partnering a co-innovation center to facilitate meter design hackathon that will develop an affordable and smart metering system leveraging local talent. 7 million naira to be won by the winning teams. We are calling all Lagosians to come watch the hackathon live from Wednesday 16th to Friday 18th of September 2020 as we pick the final winning teams. Register via this link to be part of the event: www.lagossmartmeter.com/event/sponsors. I see Lagos, where electricity flows from Bariga to Badagry and Agege melts into Victoria Island. I see Lagos, where the Okadaman is returned to his tailor shop, where the shoemaker is happy doing his job, and our programmers can code 247. I see Lagos, where our children can learn under more conducive atmosphere. I see Lagos, where everything is connected and the city shouts for joy because the light has come. I see Lagos, where the economy flourishes because of better electric supply. Winning teams. Register via this link to be part of the event: www.lagossmartmeter.com/event/sponsors. I see Lagos, where electricity flows from Bariga to Badagry and Agege melts into Victoria Island. I see Lagos, where the Okadaman is returned to his tailor shop, where the shoemaker is happy doing his job, and our programmers can code 247. I see Lagos, where our children can learn under more conducive atmosphere. I see Lagos, where everything is connected and the city shouts for joy because the light has come. I see Lagos, where the economy flourishes because of better electric supply, where the people are happy with their government and government happy with the people. The Lagos State Government through Ministry of Energy and Mineral Resources is partnering a co-innovation center to facilitate meter design hackathon that will develop an affordable and smart metering system leveraging local talent. 7 million naira to be won by the winning teams. We are calling all Lagosians to come watch the Hackathon live from Wednesday 16th to Friday 18th of September 2020 as we pick the final winning teams. Register via this link to be part of the event: www.lagossmartmeter.com/event/sponsors. I see Lagos, where electricity flows from Bariga to Badagry, and Agege melts into Victoria Island. I see Lagos, where the Okada man is returned to his tailor shop, where the shoemaker is happy doing his job, and our programmers can code 247. I see Lagos, where our children can learn under more conducive atmosphere. I see Lagos, where everything is connected and the city shouts for joy because the light has come. I see Lagos, where the economy flourishes because of better electric supply, where the people are happy with their government and government happy with the people. The Lagos State Government, through Ministry of Energy and Mineral Resources, is partnering a co-innovation center to facilitate meter design hackathon that will develop an affordable and smart metering system, leveraging local talent. 7 million naira to be won by the winning teams. We are calling all Lagosians to come watch the Hackathon live from Wednesday 16th to Friday 18th of September 2020 as we pick the final winning teams. Register via this link to be part of the event: www.lagossmartmeter.com/event/sponsors. I see Lagos, where electricity flows from Bariga to Badagry, and Agege melts into Victoria Island. I see Lagos, where the Okada man is returned to his tailor shop, where the shoemaker is happy doing his job, and our programmers can code 247. I see Lagos, where our children can learn under more conducive atmosphere. I see Lagos, where everything is connected and the city shouts for joy because the light has come. I see Lagos, where the economy flourishes because of better electric supply, where the people are happy with their government and government happy with the people. The Lagos State Government, through Ministry of Energy and Mineral Resources, is partnering a co-innovation center to facilitate meter design hackathon that will develop an affordable and smart metering system, leveraging local talent. 7 million naira to be won by the winning teams. We are calling all Lagosians to come watch the Hackathon live from Wednesday 16th to Friday 18th of September 2020 as we pick the final winning teams. Register via this link to be part of the event: www.lagossmartmeter.com/event/sponsors. I see Lagos, where electricity flows from Bariga to Badagry, and Agege melts into Victoria Island. I see Lagos, where the Okada man is returned to his tailor shop, where the shoemaker is happy doing his job, and our programmers can code 247. I see Lagos, where our children can learn under more conducive atmosphere. I see Lagos, where everything is connected and the city shouts for joy because the light has come. I see Lagos, where the economy flourishes because of better electric supply, where the people are happy with their government and government happy with the people. The Lagos State Government, through Ministry of Energy and Mineral Resources, is partnering a co-innovation center to facilitate meter design hackathon that will develop an affordable and smart metering system, leveraging local talent. 7 million naira to be won by the winning teams. We are calling all Lagosians to come watch the Hackathon live from Wednesday 16th to Friday 18th of September 2020 as we pick the final winning teams. Register via this link to be part of the event. www.lagosmartmeter.com/event/sponsors. I see Lagos, where electricity flows from Bariga to Badagry, and Agege melts into Victoria Island. I see Lagos, where the Okadaman is returned to his tailor shop, where the shoemaker is happy doing his job, and our programmers can code 247. I see Lagos, where our children can learn under more conducive atmosphere. I see Lagos, where everything is connected and the city shouts for joy because the light has come. I see Lagos, where the economy flourishes because of better electric supply, where the people are happy with their government and government happy with the people. The Lagos State Government through Ministry of Energy and Mineral Resources is partnering a co-innovation center to facilitate meter design hackathon that will develop an affordable and smart metering system leveraging local talent. 7 million naira to be won by the winning teams. We are calling all Lagosians to come watch the hackathon live from Wednesday 16th to Friday 18th of September 2020 as we pick the final winning teams. Register via this link to be part of the event. www.lagosmartmeter.com/event/sponsors. I see Lagos, where electricity flows from Bariga to Badagry, and Agege melts into Victoria Island. I see Lagos, where the Okadaman is returned to his tailor shop, where the shoemaker is happy doing his job, and our programmers can code 247. I see Lagos, where our children can learn under more conducive atmosphere. I see Lagos, where everything is connected and the city shouts for joy because the light has come. I see Lagos, where the economy flourishes because of better electric supply, where the people are happy with their government and government happy with the people. The Lagos State Government through Ministry of Energy and Mineral Resources is partnering a co-innovation center to facilitate meter design hackathon that will develop an affordable and smart metering system leveraging local talent. 7 million naira to be won by the winning teams. We are calling all Lagosians to come watch the hackathon live from Wednesday 16th to Friday 18th of September 2020 as we pick the final winning teams. Register via this link to be part of the event. www.lagosmartmeter.com/event/sponsors. I see Lagos, where electricity flows from Bariga to Badagry, and Agege melts into Victoria Island. I see Lagos, where the Okadaman is returned to his tailor shop, where the shoemaker is happy doing his job, and our programmers can code 247. I see Lagos, where our children can learn under more conducive atmosphere. I see Lagos, where everything is connected and the city shouts for joy because the light has come. I see Lagos, where the economy flourishes because of better electric supply, where the people are happy with their government and government happy with the people. The Lagos State Government through Ministry of Energy and Mineral Resources is partnering a co-innovation center to facilitate meter design hackathon that will develop an affordable and smart metering system leveraging local talent. 7 million naira to be won by the winning teams. We are calling all Lagosians to come watch the hackathon live from Wednesday 16th to Friday 18th of September 2020 as we pick the final winning teams. Register via this link to be part of the event. www.lagosmartmeter.com/event/sponsors. I see Lagos, where electricity flows from Bariga to Badagry, and Agege melts into Victoria Island. I see Lagos, where the Okada man is returned to his tailor shop, where the shoemaker is happy doing his job, and our programmers can code 247. I see Lagos, where our children can learn under more conducive atmosphere. I see Lagos, where everything is connected and the city shouts for joy because the light has come. I see Lagos, where the economy flourishes because of better electric supply, where the people are happy with their government and government happy with the people. The Lagos State Government through Ministry of Energy and Mineral Resources is partnering a co-innovation center to facilitate meter design hackathon that will develop an affordable and smart metering system leveraging local talent. 7 million naira to be won by the winning teams. We are calling all Lagosians to come watch the hackathon live from Wednesday 16th to Friday 18th of September 2020 as we pick the final winning teams. Register via this link to be part of the event: www.lagossmartmeter.com/event/sponsors. I see Lagos, where electricity flows from Bariga to Badagry, and Agege melts into Victoria Island. I see Lagos, where the Okada man is returned to his tailor shop, where the shoemaker is happy doing his job, and our programmers can code 247. I see Lagos, where our children can learn under more conducive atmosphere. I see Lagos, where everything is connected and the city shouts for joy because the light has come. I see Lagos, where the economy flourishes because of better electric supply, where the people are happy with their government and government happy with the people. The Lagos State Government through Ministry of Energy and Mineral Resources is partnering a co-innovation center to facilitate meter design hackathon that will develop an affordable and smart metering system leveraging local talent. 7 million naira to be won by the winning teams. We are calling all Lagosians to come watch the hackathon live from Wednesday 16th to Friday 18th of September 2020 as we pick the final winning teams. Register via this link to be part of the event: www.lagossmartmeter.com/event/sponsors. I see Lagos, where electricity flows from Bariga to Badagry, and Agege melts into Victoria Island. I see Lagos, where the Okada man is returned to his tailor shop, where the shoemaker is happy doing his job, and our programmers can code 247. I see Lagos, where our children can learn under more conducive atmosphere. I see Lagos, where everything is connected and the city shouts for joy because the light has come. I see Lagos, where the economy flourishes because of better electric supply, where the people are happy with their government and government happy with the people. The Lagos State Government through Ministry of Energy and Mineral Resources is partnering a co-innovation center to facilitate meter design hackathon that will develop an affordable and smart metering system leveraging local talent. 7 million naira to be won by the winning teams. We are calling all Lagosians to come watch the hackathon live from Wednesday 16th to Friday 18th of September 2020 as we pick the final winning teams. Register via this link to be part of the event: www.lagossmartmeter.com/event/sponsors. I see Lagos, where electricity flows from Bariga to Badagry, and Agege melts into Victoria Island. I see Lagos, where the Okada-man is returned to his tailor shop, where the shoemaker is happy doing his job, and our programmers can code 247. I see a Lagos, where our children can learn under more conducive atmosphere. I see a Lagos, where everything is connected and the city shouts for joy because the light has come. I see a Lagos, where the economy flourishes because of better electric supply, where the people are happy with their government and government happy with the people. The Lagos State Government, through Ministry of Energy and Mineral Resources, is partnering a co-innovation center to facilitate meter design hackathon that will develop an affordable and smart metering system, leveraging local talent. 7 million naira to be won by the winning teams. We are calling all Lagosians to come watch the hackathon live from Wednesday 16th to Friday 18th of September 2020 as we pick the final winning teams. Register via this link to be part of the event: www.lagossmartmeter.com/event/sponsors. I see a Lagos, where electricity flows from Bariga to Badagry, and Agege melts into Victoria Island. I see a Lagos, where the Okada-man is returned to his tailor shop, where the shoemaker is happy doing his job, and our programmers can code 247. I see a Lagos, where our children can learn under more conducive
On July 30th, Mr. Governor launched the Lagos Smart Meter Hackathon, and we will requests from as far away as India asking if they could participate. Our intention was not to provide a solution that was not the best solution available, and so we encouraged everybody to join us to do this. Interestingly, at the end, just before the deadline, we had received 65 submissions. For us, we were expecting to get 10 submissions and then let's see what we can do with the 10, but we received 65, which was shocking. What we next did was to arrange experts from the sector, both the tech space and also the hardware space, to come in and review those 65 submissions and whittle them down to 5 hardware submissions and 5 software submissions. Ladies and gentlemen, over the past few months and weeks, these people have spent a lot of time trying to design a solution that could work. And the solutions that we received were impressive indeed from the expert judges, from the expert judges' mouths themselves. So what we expect to see is a solution that can work. When we started this, a lot of people said it was likely not going to work and that we'd receive some submissions that may not be useful. But what we saw were very impressive submissions. People had taken their time to put together a solution that they believe would work in Lagos and for Lagos. And we believe that if it works in Lagos, we can export it to the rest of the country. Lagos has always led, as you know, and everybody has followed. We expect that if we make a success out of this, we expect the rest of the country to either look to us in a leadership position or follow us into the future, the 21st century economy of Lagos that we're trying to provide. Now, to encourage the people who are participating, there will be a prize money of 7 million naira to the winners, and also consolation prizes to the runner-up, the first runner-up and the second runner-up, and also a mentoring opportunity that will support them to develop the businesses that they have found themselves into. In addition to picking a winner, we also hope that we have encouraged a lot of young people to discover that beyond trying to get the job, there are opportunities to create within the industry and also find businesses that we can support. On the judges table, we've got financiers, we've got industry leaders, and these are people who are very keen on what these young people have to provide. We were very careful about selecting the judges that we have here. We have people who can finance your dreams, we have people who can buy into your dreams, and we have users of the products. So I encourage you, as you're presenting your solutions, to realize that even if you don't win, there's a future for you in this sector. After the winners have been announced, we're going to go into a rapid prototyping mode, where we will work with our industry partners to prototype the solutions that they have provided. We're then going to work with also the manufacturers to see how we can mass produce this product. We're going to test these products, and then we're going to commercialize them. Without further ado, let me thank you all for coming so that we can start the process. And I welcome you to the hackathon. And over the next 3 days, culminating on Friday with Mr. Governor and Mr. Deputy Governor coming to present the prizes to the winners and also assure them of the state support. Today, we're going to go into the hackathon itself and start to review the products that have been submitted. Thank you again very much for your support.
Thank you very much, the Honorable Commissioner for Energy and Mineral Resources, Lagos State, Mr. Olalere Odushote. I'm really encouraged because for a competition, a lot of people think it's about winning, but making it to the top 10 is a win on its own. And having the opportunity of our distinguished panel of judges to hear your ideas is something that is a golden opportunity. So please make the most of it. The way it's going to work, we'll have 5 teams. They will present one after the other, and they'll have 10 minutes for their presentation and 5 minutes for questions from the judges. So a total of 15 minutes for each of the teams. The first team that will be presenting their idea is Power Bit Crunchers from Lagos State. Warm round of applause for Power Bit Crunchers. They're already here waiting to lead the presentation. And like I mentioned earlier, please, let's get the word out there. Let's take our pictures, record our videos, Let's share the innovation, the technology that's happening right here in the Center of Excellence, Lagos State, by using our hashtags made by Lagos, Lagos Smart Meter, and Lagos Hackathon. So as they take to the stage, another warm round of applause. Let's encourage them. It can be very daunting.
Our device was active and could transfer data online. Now, part of data that could be transferred when the device is off is tampering, the occasion of tampering, because it's possible for you to tamper a meter to try to open up a meter when there is a power outage. Now, this can detect that because there's an inbuilt power source in it. Now, secondly, our meter also logs in this information real time online as at the instant they occur. So at the instant a tamper event occurs, this data is uploaded online. Now we are going to turn it on. Now this is a practical situation when power is restored from the mains. Now you can see it's already connected to the mains. Now another set of features is that our device logs power outage and power restoration times. This is necessary because we found out that during the process of troubleshooting or any kind of fault event, is necessary to identify what caused the event. Now, sometimes there could be a power outage because of an accident or something else, or there could be an actual power outage because of power from the mains. Now, this is able to tell you when and what caused the power outage. Now, on our screen, we have a basic feature which should be common in any smart meter. One of those features is the ability to tell how strong the network is. Now, we are using a universal API system that allows this device to connect with your common SIM card, your common SIM cards. Now, part of the issues with installing a meter that has to work with the network is you could install it in a place where there's no network, and you have to be able to identify that. Now, on our screen, we have that feature. You can see the bars here showing the strength of the network. Now, another thing on the screen you can see here is the battery level, the inbuilt battery level. Now, the device is supposed to be on permanently, but there are conditions where you could have a power outage for 3 to 4 days. Now, what that means is that the device will surely run out of power. Now, but before that happens, this thing, it goes into a power down mode. It's actually not technically off, but it's a power saving mode that the device goes into. As soon as power is restored, it wakes up from that mode and continues the process. Now, on our screen also is the power measurement. You can see an approximate value of the average power being consumed right now on the screen. This is our 127 watts And that is the power there, plus the inbuilt power consumed by the meter itself. Now, our meter is able to do anything smart that can be done. You can turn this meter on and off remotely. Now, you can also measure what state it was before you turned it off. Now, it's possible for power to be available and you turn it off. Now, that is a state. We are able to identify it in our software. It's possible for power not to be available and you still try to turn the device on. That is a state we can determine on our device. Now, this is the software, the online platform that shows the state of this meter. And this is supposed to be this is supposed to be the customer's dashboard. The owner of this meter, when he buys the meter, he registers it on the platform. The meter has an ID that is unique to that customer. All that information is tracked by this software. Now, every meter must have a unique ID because we expect that we are going to manufacture several. Now, each meter sends its information on a channel, and that information must be addressed. So the metering and the number, the meter ID is the address for that particular meter, because we could have thousands of meters sending to our web platform. So we're able to identify which meter is sending this data and where it's sending it. Now, another key feature of our meters is we've identified that locally, a common problem is bypassing. Now, bypassing is a very big problem because while we've been able to identify that bypass occurs, we have also been able to identify that the amount of energy being stolen, but the key challenge is not being able to identify where the theft is occurring. Now, this meter has a feature that allows you to detect where this meter has been installed. Now, that function is a GPS function, actually. It captures the location of that meter. Now, we have found out that with this parameter, this last parameter, we can point out where bypass is occurring. Although it might not be able to work on a single meter because you need a network of meters for that to happen. But with our algorithm, we are able to identify where bypass is occurring. That's a key feature we have tried to solve in this competition. Okay, now another feature here on our screen is the average load consumption. I think I've talked about that. Now, most customers don't just want to buy a meter that shows them how many units is being consumed. They also want to be able to measure, this my AC, how much power is it? This my TV, how much power is it? Now, with this meter, you should be able to calculate averagely how much power each of the devices are. You could need that information for something else, or in fact, but this information is also logged online. So you have a statistics of your meter usage for every customer. Part of every customer wants to minimize how much they spend on energy. You want to identify which load is consuming the most power in your house. You want to be able to track when to turn on these loads and when to turn them off. Now, with this information, you'll be able to do that and manage power effectively. Now, I'm going to try to, okay. Okay, we are going to try to turn off the load remotely. Now, this is a key feature that is necessary for every smart meter. The stakeholders, which is the distribution company, for some reasons might need to turn off that meter. And that could be suspicions of tampering or suspicions of bypass. Now, they have to be able to do that. And this is the software that does that. So it's going to turn it off. has turned the meter off remotely. So it's able to do that from the web platform. Now, immediately this happens, now, this is an event that has just occurred. The meter was on, power didn't fail, but it turned off the load. Now, that's an event that is exceptional because this is not from the mains. This is usually not a fault from the mains. Now, that information is sent online, and that usually takes about 10 to 20 seconds to send that information online. And when that is done, it can also be turned on. Now, note that information events on this meter is sent to the web platform every hour. Now, what that means is that there could be problems that occur within the hour. Those are special trigger events. When they occur, this device sends that information instantly. It doesn't wait for the next hour to send the report. So in between hours, you could have data being sent at certain intervals, showing you that something special has occurred on the meter. Thank you very much.
The end of your presentation, and then we move to Q&A.
All right. Okay. Now we have also built an accessory. It's an accessory. Now, for every standard meter, you will have a situation where technicians might want to troubleshoot in the field. Now, this device allows us to connect via an extra port at this end and via a meter reading. Now, this connects and via a special equipment. We didn't want to go so much into the details of building a handheld device, so we have just attached it to a computer here. Now, the attachment here allows the technician to read information from the meter. The technician cannot write any information to this meter. It's just for reading purposes. You want to know if this device is registered at the location it is representing. You want to also know, okay, if there's power in the device, if it's feeding out. You also want to know how much units, in case probably the display is bad or something like that. These are things you can find out on the software. And this is a software not completely done yet, but this is how it is. This is the software interface for the technicians, not the web platform. Now, all these can be on a handheld device. We just did this because of the time. It could be on a handheld device, which the meter should have. I believe every standard meter should have that accessory for technicians to troubleshoot and find out problems in the field. Thank you very much.
Thank you very much. A round of applause for our first participant from the hardware team. And they come from Lagos, the Center of Excellence, Power Bit Cruncher. So before you started your presentation, we wanted you to actually introduce yourselves. Let us know what you do, maybe 2 or 3 lines. Are you working? Are you a student? Your background in technology.
All right. I am Oloma Ibrahim. I attended the University of Benin. I've been a hardware developer since my undergraduate days. After my service, I set up a small firm, startup firm, Android Systems Limited, and so far I've been managing that firm.
Okay, and your partner here?
My partner.
Okay. My name is Peter Okuma. I'm a graduate of environmental engineering. I fell in love with hardware and I started working towards it. I learned it, and today we are working together as a team. This is not the first smart meter we have developed. We have been working till we got to this stage, and that's what we've been doing.
Well done. Good to meet you. Now it's time for the questions and answers. If you wanted to applaud them, let's go ahead and applaud them. Yes. So we have 5 minutes for questions. A microphone will be given to our judges. So maybe if we just have by signifying of hand. Okay. I see so many hands up. So please, can one of the ushers pass a microphone? I'll keep this one here just so they'll be able to answer the questions. Apologies while we're waiting for the microphone. I hope we've all been taking pictures, doing recording, sharing just the sheer amount of talent that we have to the virtual world. So I believe a microphone is coming, but while that is happening, I'll just make do with this one.
Thank you. So good morning, Powerbit Crunchers. Very impressive presentation. Well done. A few questions from me. So first, the cost of the meter, if it's something that you already have produced, so what the approximate cost is likely to be, because that's a key part of this. Secondly, is it a product you already have in the market, or is it just going to the market, or is it a prototype or just an idea? And then thirdly, can you access historical information? So for the customer, I can see my spend over time. I can see what you talked about, for example, about seeing how much power a device is consuming. Can I see what it's been doing over the past 1 year and things like that? Thank you.
Okay, just before you answer that question, we'll just get another set of questions and then I'll
Thank you very much.
Back.
Olama and Peter, you have done a great job in your proof of concept. However, I would like to take you up on some few designing techniques and the standard that requires in the domestic meters. In your consideration of what type of meter you want to produce for consumer, are you aware that there is a standard that is required in terms of accuracy class, like class 1, class 2, class 0.5, depending on what design you want to make? That's one. Secondly, are you considering the fact that when you are putting cost into consideration, all your primary sensors and the microcontroller you need to use must be carefully selective such that it will be able to meet up all the requirements of the applicant concept, because they are looking at a very wide range of communications in terms of in and out information. So your microcontroller, your AFE, your SOC must be carefully selected, and that goes with a lot of cost. Also, in this design, did you put it in consideration, the test, the accuracy, does it pass the necessary criteria that will make it useful for a domestic house or even commercial houses? Because you need to pass it through that certification. So what method did you use for calibration to ensure that it complies with a metering code or IEC code that is required for domestic or commercial meter? Thank you.
Thank you, sir. Quite a number of questions. I jotted some of them down and I'll just give this to you. So we had questions on the cost, whether this is a prototype or is already in the market, and also if you can access historical data. So let's start with those three questions from our first judge, and then we'll move to the other questions.
Okay, yeah, part of our considerations when building up this design was to reduce costs to the barest minimum. The target in the website then was around 15,000 naira per unit. Now, to achieve that, we had to trade off a lot of things. Now, on this device, you can notice that key parts are absent, which means you can only do via regular SMS or web platform. That was to cut down costs. Now, secondly, if you open it up, you find out that we have avoided the use of modules where we just buy plug and play and plug-in modules. We have built everything from scratch, which means our modems, our components, everything were selected. Now, we have been able to achieve the cost of 15,000 naira per unit, but it could go down further because on this device right now, we didn't use surface mount components. The surface mount components will drastically drop our cost and reduce the size of the enclosure itself. So that is what we have done to ensure that we fit into our cost requirements. Now, secondly, on the issue of data usage, everything here is sent on the hour to the customer's dashboard. So the customer can actually review a history of all his power usage. How much energy he has been consuming, what particular times he even consumes. This meter keeps track to the web platform. Yeah. Okay. So the last
Question had to do with the stage. Is this something already in the market or
okay.
is a prototype?
Now, at this stage, it's a prototype because there are requirements that must be passed before we can take this into the market. And as a small company, we presently don't have the capacity to produce and push into the market. So this is still basically a prototype at this stage.
Okay, and the next set of questions had to do with the class, depending on the design, and also if it has passed through the necessary steps to test for accuracy. You've carefully selected all the metrics, method of calibration, I believe.
Okay. So this meter is a single phase meter for residential homes. Now, it's been designed with the most accurate chips in the market. The AD7755 is a standard chip used with a high accuracy for measuring power. We use that device, that chip here, and we're able to calibrate with standard loads by considering the frequency response and all that. We logged it on over a period of time, found the most responsive frequency calibration settings, and we use that for our device. So with a chip of about 0.1% accuracy, which is what the manufacturers of those, that chip tell us, we think meets the issue of accuracy. Now, in the design, cost is also a major issue. And like I said, as it is right now, we have been able to meet the conditions stated on the website, but we know it could be dropped further. And that's because we haven't used surface mount components for this particular design. Now, the challenges with using surface mounts here is that you need special equipment to put them together. But in order to quickly prototype, it's easier to use a true hole component for your design. That is on the issue of cost. So things are answered the questions. Thank you.
Okay. I think 5 minutes has been exhausted. We'll probably extend it to about 10 minutes and just keep to time afterwards.
So I'm going to try to keep my questions as minimal as possible because I took accurate notes of a lot of what you were saying. Let me first start by commending you, I think, in such a short period that you've made our work look so easy, and pretty much drawn, or shall I say, created a prototype that, could be commercialized. So let me commend you and your team, first of all. I would also like to say that I was just telling the Honorable Commissioner that this is a dream for me. It's a dream because it's exciting to see that Nigeria does have that capacity in country. And we really may not need to go to China. For me, fantastic, because I'm sure Engineer Balogo and I here know the headache that we go through with the Chinese. We're trying to source our components and materials and things like that abroad. So it is thrilling for me. You have no idea. And in just a few minutes, he's touched on some key components that, when you're talking about a meter and what a meter needs to do. But my questions for you are a few. First, I'm not sure you talked about how your meter will communicate. Is it a smart meter or is it just a prepaid meter, right? Secondly, I also noticed that you didn't have a user interface unit, and you don't have to. So I'm curious to know whether you created something that does not need a UIU, right? It's that's forward thinking. It's something that I think you should definitely think on, if that's what you're doing. Because I noticed you mentioned the dashboard. Now I don't know whether that's the dashboard on the utility side or on the user side, right? So that's important. Also, a lot of these materials, did you have to import them or did you get them locally? Right. So were they sourced locally? And then lastly, you had mentioned, right, this was the amazing one. Well, I thought was interesting anyway. How can, or what have you done? Maybe you might want to share that later. So just know Mojak is interested in talking to you. Okay. But how How have you been able to measure, right, the different load, or at least the appliances or devices in the customer's home that enables the customer to know my AC is is using pardon me, is consuming this much electricity, and therefore come up with a cumulative, right, total of the energy consumed, right? There's some interesting things going on in the industry today about that. So I'm curious to know maybe if you innovated or done something different. Thank you.
Thank you very much. I believe that will be our last set of questions for this team. So the first one on communication, how do you communicate? And then we can move to the question on user interface.
All right. Communication is the use of a universal API. We use information as a paid service that allows us to send data to communicate with the hardware with an online platform. It's an IoT-based platform. It works with the SIM. It's universal. Whatever SIM you plug in here, you put into this device, can be configured automatically. Just the way you buy a new phone and then you receive automatic settings. This information can be sent straight to the meter. So at the instant you buy it, it's blank. You can't do anything with it. Configurations have to be sent from the meter distribution company. And that is the dashboard. That's part of the dashboard. Right now, what you can see here is actually the user's dashboard, but we also have the stakeholders dashboard. Now, the distribution company can configure this device. We'll have to configure this device remotely for it to become active. Otherwise, it's just a piece of metal in your house. Now,
the question on the user interface, do you have one?
Okay, yes, ma'am. This is the user interface. Every customer is supposed to have this. It's used just from the laptop. You don't have to attach any other thing. Yes, yes, ma'am.
And then the dashboard you mentioned that you have for the customer as well as for.
Yeah. This is actually, it's a complete web platform. We have the aspect for the customers that allows each meter owner to create an account and have every information about his data usage and power usage on his dashboard. Now, one of the key features you mentioned is that ability to use this meter to detect how much power you are consuming at home. On the screen here, you can see that outrightly. You could turn off your light bulbs. You want to measure your AC, turn off your light bulbs, turn off your AC, and in 2 minutes, it gives you the exact power consumed by that AC. We believe this is a necessary feature for any smart meter or anybody who really wants to manage power in his home.
Okay, and finally, the parts, were they imported or sourced locally?
Yep. Electronic parts are practically sourced up from abroad. But they are cheaper when they are coming in as components as opposed to an already finished device. So most of our components, that's the electronic components, were sourced abroad, but the enclosures, everything else was done locally here. The cables and everything can be sourced locally here.
Thank you very much. A round of applause for Power Bit Crunchers from Lagos State, the Center of Excellence. Okay. Very quickly, sir.
Quick one, just to advise them, because they've done a great job, really. However, let me give you a bit of background when it comes to this design. Whenever you want to design any solid state devices, all we need to do, first of all, go to the standard book. For instance, let's say, take Ghana, for instance. There is IEC standard book for metering design. Then you go to the country code design standard. They always have a standard. Study the standard very well. Look at all the various components, solid state components, that will be able to meet the standard. Otherwise, we'll just be doing classroom experiments, school experiments. Because if I plug this thing to a house, it may not be able to meet all the necessary Nigerian standard that will meet. So you have done very well in terms of POC, but you need to upgrade your thinking because in Nigeria, we use what they call STS protocol. Besides STS protocol, there's some other protocol, DLMS protocol that Lagos State want to comply with. Those are the standards you need to study and now find that microcontroller and AFE to be able to hold on to those memory because they all require a large memory size. Then for your PCB, how do you design your PCB? You said you don't use SMT component, you use True component. True component will make your design to go box. You need SMT component. These are things you need to study. On the component, I'm already fighting with the federal government that electronic component generally should be 0%, such that it will encourage development like this, because we can as well produce the component by the time we now have the volume that is required. Thank you very much. Keep it up and God bless.
Thank you very much. And that was Power Bit Crunchers. Please note that today is strictly for hardware presentations. So the software teams will present tomorrow.
So you may need to give us some more information in order for us to score you, or at least fill this in, right? I think you mentioned that your communication interface is IoT based, right? Also, and I think like Engineer Balogun was alluding to, are you DLMS COSEM compliant? Would you know that much or not yet? You don't know that, okay. And you mentioned there's no need for a UIU, right? No need for a user interface unit. And then how quickly does it dump data on the backend system? Do you have that information? By your so we'll need to know that, how quickly your meter dumps data on the backend system. So meaning if you contact the meter, how quickly do you get the information, right? Also storage, the storage capacity. Okay, stored online, so you don't have remote, so it's remotely, there's actually nothing in the meter. Interesting. So what if you have downtimes or issues online and you may want to communicate with the meter? Is real-time data, okay. All right, and so head-end systems. Does your head-end system have a summary dashboard? We have that. Okay, that's it. Thank you.
Thank you very much. We have our next team coming out, and like I mentioned earlier, this is strictly hardware presentations. Tomorrow at Access Bank, we'll be receiving presentations from the software team. So for the people coming out, please focus on the hardware. The next team that will be coming, yes, let's give them a warm round of applause. The next team that will be coming out to present their own hardware solution come all the way from the Center of Learning, Kaduna State. Let's applaud Tech Wizard. Tech Wizard, they'll be coming to do their presentation. So I believe they're already prepped and probably just carrying things. So far, how has it been so far? Are we motivated? Are we encouraged? Are we happy? Okay, please let's tell them outside, meaning the virtual world. Let's communicate that feedback with them to let them know that Lagos is working. Lagos is supporting the growth and development of local technology, nurturing local talent. So I can see that Tech Wizard in the red t-shirts are coming. Please note that your presentation should focus on hardware. You have 10 minutes for presentation, and I'll be giving you a 2 minutes warning, and then I believe 10 minutes for questions. I think this time we can tailor our questions to what the scoring criteria is. So Tech Wizard. As they set up Tech Wizard, before you start your presentation, we want to know more about you. Are you working? Are you students? How did you get into technology? Let's just keep it short and sweet.
Oh.
You can start.
Right.
Oh, I believe you've been mic'd up, so
Yes.
that's great.
Oh, it's on.
So just speak.
Right. Good morning, everyone. My name is Love Adioshun, a graduate from Covenant University. I majorly am within the power industry of Nigeria. I started my journey there in 2015 during an internship while back in school. And then I got into technology in late 2018 when I joined International Technology, the team that made the Tech Wizard meter. I currently work, or I'm currently serving in Lagos State. I work in Smarterize Integrated Solutions. We are a third party, a private institution that offer energy consultancy. So I've had a lot of interactions with smart meters and energy systems, and also had internship across two distribution companies in Nigeria, Kaduna Electric Distribution Company and Ikeja Electric. Thank you.
Thank you, and let's get to meet you. Don't worry, you can just speak.
Hi, good afternoon, everyone. My name is Babatunde Adegoke. I'm the founder and CEO of Tunansha Technologies, a technology that provides technological solutions to individuals and companies. And I've done several projects for individuals and organizations. I've done projects for Wema Bank. We did a project for Wema Bank last year. I was asked to design automatic storage protectors. And we installed in 10 branches of Wema Bank. So we have done several projects. Matrak is also one of our customers. We've done diesel smart monitoring system for them. It's actually IoT-based device that can be used to remotely monitor your diesel level from anywhere around the world. It comes with a mobile app. And thank you very much.
Thank you very much. So Tech Wizard, you have 10 minutes. So by 12:10, you'll have to stop the presentation to allow for questions and answers.
Okay. Okay, good morning once again. I'll start with giving a brief description of our system here. Our system has been designed using an ESP32 microcontroller chip. It was carefully selected because of our objective to have our system be within the limits of the cost specified in the functional requirement document. And also, we chose the ESP32 microcontroller because it has other functionality that makes it quite robust within this Nigerian market. So the ESP32 chip has been interfaced with other modules to allow for a smart meter that is very flexible. So using a microcontroller means we can program it to do about almost anything that we want to. That gave us the edge in delivering on all the requirements stated in the document. We have here, let me just describe this. We have here our LCD, a 16:4 LCD display that shows the voltage. The voltage shows the frequency, it's still coming on. The voltage, the frequency, the load, and also the status of the GPRS network. So as stated in the document, we are meant to use a GSM module for communication. Also to mention, our ESP32 chip has a Wi-Fi module incorporated into it. So should in case our system is installed in a place where the GSM network is a little bit messy, the customer can have the option of connecting this meter via Wi-Fi for remote access. And then also we have here a circuit breaker. This circuit breaker was specially installed for reverse current flow conditions. So this is very necessary because we find out that sometimes, from personal experience, some customers have issues in the house, and when they turn on their private generators, there's this reverse current flow that can affect meter. So this strips off when there's any condition of a reverse current flow.
And
here,
just a second, because you're pointing out things, and I want to invite the judges. If you want, you can come to the table to actually look at. You call this what, the circuit breaker? Okay, so please, you're encouraged, judges, yes, to come to the table to have a look. Please carry on.
And then here we have an external port for a battery system, as required in the document. Case a from this and out due to outage for a long period of time. And then also here we have the IR module that is communication module. And this is not the major communication module that is incorporated. We had the option and also using Wi-Fi. We decided to use USB installed within the meter so that not anybody can have access to it. Also to note, we have a tamper switch intertwined with our system. should in case an unauthorized personnel tries to make access to our system, the admin or the distribution company, the utility company will be alerted through an email sent to them. All right.
Okay. So the key features. What are the key features? Okay.
All right. So why is this setting it off? Pardon. Why is this setting it on? Our GSM module has a GPS functionality, and this gives us an advantage of allowing the utility company to know the exact location of each meter installed on through Google Maps. So we've also integrated this using Google Maps. The GSM module has a GPS functionality, so every meter has a location, has an ID, and the utility company through an admin dashboard can see the location of each meter. And why is this necessary? Should in case there's a tamper, like I said earlier, an email will be sent to the admin, and when he logs on, we have, which we're going to also show, the admin dashboard that give you the tamper meter. So in case there are multiple occurrences, we have a simple dashboard that lists everything down. You can just click on them, check the address, and then you can also send your field agents to go address the issues. Also, we have for the prepayment system, we integrated paystack system. First of all, our system was required to allow for CTS token loading, and the minimum requirement for this on the hardware side is that we have at least two EEPROM intertwined with our microcontroller, and that has been done, meaning that we can make use of third-party vending softwares like iTron that Eco Electric use, and different kind of third-party vending softwares can be integrated with our hardware. It's about that.
So now the EXP32. Let's talk about the EXP32. Sure.
Yes, yes, we are.
Okay. So I won't get electrocuted. So here's the internal structure of our energy prepaid meter. We have EXP32 chip on our meter. It runs at the speed of 80 megahertz. And you can see here we have a GSM module with a SIM card, which enables the meter to remotely communicate with our server. Here we have a relay that controls the load. We have the terminal connector here. Here is our tamper switch for this one. This is our tamper switch. Let me pull out the GSM module. This is a GSM module that allows the system to communicate with the remote server. I choose a SIM card. So I'm going to return this. Okay. This is a 3G module, which works with 3G. And we have here a voltage sensor. And underneath, we have the main current sensor that reads the current going to the load. Underneath, we also have another current sensor on the neutral line that reads the current going to the same load. Sorry, I need to show you something. We have a PCB that we did in China. We've been to this for years. So it was so easy for us to come up with this solution under 3 weeks because we actually got the news. It was very late before we started. So this is a PCB that we did in China that we use for our design. So you can see it looks like imported, but it's not. This is our design. We used the British simulation software to do everything. Then we now sent Algaba 5 to China to make a PCB. This PCB costs less than $1. So we can even manufacture prepaid meters at the rate of 5,000 instead of 10,000 naira. So we have few components here. So we actually chose ESP32 because we wanted to slash down the price drastically. So we didn't want to have extra components in our design. So the ESP32 takes care of everything. It measures the frequency, the power factor, the current going to the load, tamper, theft, and so on. And the ESP32 also has Bluetooth functionality, Wi-Fi functionality, like my partner said. Our meter as well works with Wi-Fi network if you don't want to use GPRS, that's the SIM card. So, and let me couple, but let's do the testing. No, okay, sorry. So you can remotely control, the customer can remotely control his or her meter from anywhere around the world. If you're not around, you can log into the app, shut down your load to save your power consumption. The admin can as well remotely shut down customers' meter in case of theft. Our system is automated. If someone tampers with the meter or bypasses the meter automatically shuts down and sends a signal to the server. So it is fully automated. You don't even need anybody to shut down the customer. So the customer has to make a complaint to the power holding company. The power company will log into the database and see number of meters that have been tampered. Then from there you can restore the customer's meter. So here the system is coming on, but it's booting. Sorry.
You have
It's
about
booting.
2 more minutes.
Yeah. So we want to quickly do a
minutes.
demonstration. We're going to use our phone. We designed 2 URLs, one URL for the admin. So our solution can take up to 100 million subscribers. So it is dynamic. So we also have another app, a URL for subscribers to remotely control their meter. So from the dashboard, you can monitor things like power, voltage, your balance, and we also integrated pay stack payment into our
You have about 1 more minute. You can use this.
Okay. So we want to do a simulation. So I have for me, I'm on the admin dashboard. So I'm logging in from my system and I'm using my phone to log in to control the meter.
As mentioned earlier,
Everything,
our
we're waiting
judges
for the
can
network to
come
come up. We're waiting for the network to
have a
to
look.
come up. Yeah. I need someone to log into to the admin dashboard and customer dashboard. So the URL to the customer dashboard is checkwizardmeter.ketroot.com.
Did we get that?
techwizardmeter.ketroot.com. That's the admin dashboard. D.com. That's
So can you do it slowly? Tech wizard
techwizardmeter
meter
dot KETHOOD.com. Ketwood. Yes, Ketwood. KETHOOD.com. Yeah, D. KETHOOD.com. So the username is Tunde, capital letter T, then UNDE. Password is A, 8 places. A in 8 places.
is that small letter or
That's small letter.
so A 8 times?
Yeah. That's the password. A times.
A. Small letters. So you just keep pressing 8 till you get to the 8th time. I believe time
That's
is up.
the admin's URL. Now for the customer is subscribe.ketwood.com. The same password.
So A till you've pressed A 8 times.
Yeah.
Tech Wizard, is that it?
Yes.
Yes, because time is fast
So,
spent.
I
we
want
need
you to
go
see the readings on the dashboard
Okay.
from the last testing we did.
So do we have any winners, fastest fingers, anybody?
So on the dashboard, you can see the balance, the voltage, frequency, function, so on. Okay.
Right. Well done. A round of applause for Tech
Yeah.
Wizard.
Okay.
I like the interactivity.
Yeah.
So do we have questions? I'm looking at time. We also have our judge who is joining us from Zoom. I believe he's out of the country, Mr. Bumi Akiyemiju. So if you do have a question, please, you can unmute yourself and ask the question.
Okay, can you hear me?
That's the network.
Can you hear me now? I have a question.
So perhaps you can unmute yourself. If you can hear me, Mr. Akiyemiju.
I can hear you. Can you hear me?
We can't hear you, unfortunately.
Okay. Can you hear me now? I think maybe there's some audio issues.
Go on, sir. We can hear you.
Okay, you can hear me now? Okay, fantastic.
Yes, sir. We can hear you.
Fantastic. Well, I just want to say good job to Team Tech Wizard. Great that you gave us access. I can see it, you know, and I know that it must have taken quite a bit to pull this off. Just a couple of questions. I like the fact that you're also using the ESP32, so really focusing on a compact design. But my question is mostly around scale and how you can attract investment. It's fantastic that you have companies like Mojek here today, but they will be asking, now this device that you have designed, I hear that you believe you can achieve 5,000 Naira, which is brilliant. Now, as you're trying to, as you've gotten it to that level of cost, I think, again, one of the questions we're concerned about is standards, Nigeria standards, STS meters, and so on and so forth. Secondly, when you're designing, even though you're designing for Nigeria, we like to think global as well. So do you think that this is a system that can scale across Africa also? The last question is, if you were going to get some investments, if you're going to ask for investment, how much would you ask for? And how many meters would you be able to produce? And what timeline would it take for you to actually be able to get to market?
Sir, for the wonderful questions. Did you get all the questions looking at cost, scale across Africa, investment, and timelines, and how much you'll need? Okay, so can you try your mic? If it doesn't work, we'll... Okay, let's temporarily use this one.
Okay. Firstly, I want to apologize that we didn't demonstrate everything, and we're having an issue with the network of the SIM card we're using. We're trying to, so there's no communication now with our meter and the dashboard. So it's showing you the last time we, which was about 10, 11 this morning, when we checked it. So you can see that also on the dashboard. We're trying to get that off. We're trying to troubleshoot it now. But should in case, we also have a video we did this morning, just a last check before coming here, and we can also show that it is required. But then for the cost, so one of the things we did, knowing that most of the equipment that we selected are not produced or readily available here, the vendors, we got some of them from Hub 360, sells them at quite a high price. So the prototype is not 5,000, definitely. But then one of the things we did was to check producers of this equipment and check for the block prices, and we have this justification in our document which we submitted. For the scalability, like my colleague mentioned earlier, we've already had some systems in place. And being that the PCB board which we designed had to be sent to PCB Way in China for them to print it out for us and send it back. And knowing that these systems are best assembled and fixed in companies like in China, I think it's going to take, for the timeline, I'll give him the mic to talk about the timeline, but for the cost, investment cost, I haven't done the justification for that either.
Okay.
Okay. Tech Wizard, thank you. You tried, but I still consider all your concept as a university experiment. It's simple because for any meter or for any electronic device to be used on a commercial basis, there are so many considerations, and it all boils down to standard. Your choice of microcontroller is an old controller, is ADC, analog front end, that has a limited resources compared with what is required by standard. Nigerian standard is one of the most toughest to meet standard when it comes to standardization. Our requirements are very high. Let me start from the basis. We have 16 cable, like 4 that comes from the pole that will enter a terminal block. In selection of the terminal block, you must first of all choose the material. It must be a bimetallic material that will be able to withstand aluminum and copper conversion in terms of heat tolerance. Our voltage profile in Nigeria is very vulnerable. So in selecting all your devices, at the base current is very selective. Now, your choice of your current sensing devices. I don't know whether you use shunt or CT.
We use CT.
You use CT.
Current transformer.
Okay.
Yeah.
Now, in choosing CT is more expensive.
Yeah.
Shunt is cheaper
Yeah.
if it's considering single phase.
Yeah.
So in selecting CT, it's go a long way in improving your cost. Now, the terminal block alone to produce the case and every other thing, the selection of material that you are going to use must be fire resistant, because these are products that can be outside and should be able to withstand a larger heat tolerance up to 80 to 70 degrees centigrade. These are things that all this material, that is the plastic section of it, that it has to undergo. There are tests in the laboratory, that is national laboratory, that are going to pass through your design, that you must be able to withstand. That equally increase your design cost. Let me give you an instance. In LME, they produce some PVC material, but you cannot pass the test of the body case requirement of Nigeria. We have to make sure you go to Saudi Arabia to buy the chemical that will be able to meet that level of good temperature tolerance in Nigeria. That is one. Now, your PVC, your PCB, you will have just talked to me. I can produce a PCB for you. I have a laboratory that can produce that. And I will even produce it cheaper than China. So that's one of those things. So in your cost consideration, your selection of microcontroller, every other thing, there's so many things that is totally outside Nigeria and IEC standard. But the proof of concept, the fact that you have the entire concept flow of what is required is very appreciable effort from your side, and you can be used and you can be trained that this meter will meet the international standard across the globe. Well done.
Yes, sir.
Thank you,
sorry
sir.
for interrupting you.
So you can respond. Let's just take the next question so we can manage time. I believe we'll be having the same judges asking questions and giving
We're
feedback.
the users, that's why. Tech Wizard, thank you very much. Your presentation was very insightful. I've noticed that you said it could be either GCM or Wi-Fi. So does that mean you're using 2 modules, communication modules in your design? And also, I'm keen to note, and I think Engineer Balogun may have alluded to it, that your terminal block design, I don't quite see one where it's able to withstand well, first of all, the type of material that you're using for it, right? And also the maximum current that it's going to be able to withstand, right, in country. My third question is, I also noticed that in order to be able to get to your SIM cards or your communication modules, they are inbuilt, right? So that automatically means that you haven't considered, or maybe you haven't, you have to explain it, tampering, because that means if anyone's gonna come check the meter or what have you, they have to open the meter to get to, right, your communication module. And then lastly, well, I think you sort of answered that your materials were not sourced locally, that you didn't source them locally. And do you have a do you have a UIU in your design, or
Yes,
is it remote
we
communication?
have UI UX in our
For the
design.
for the end user, there's a
Yes, we
UIU.
have a mobile app, we have
Right.
URS.
So I think like Mr. Bumi asked you, it would be nice to know if you were to be designing a prototype, what the cost,
Yeah.
right, inclusive of all these considerations would probably be. Thank you.
Thank you, Anne. Okay, I'll let Tech Wizard respond to the first set of questions and we'll take. I believe your microphones are working now, so. Okay.
Okay, permit me to respond to her question, then he responds to you, sir. So you asked about the GSM and the Wi-Fi. So the Wi-Fi, like I said, comes already incorporated in the ESM32 chip. So that's one of the things we considered. It acts like a redundant option. So should in case GSM fails, we can set it up with Wi-Fi. So something is trying to do now because our GSM failed. And then for next, you asked for the terminal block and the maximum current. So as specified, it's 100 amps. System allows for 100 amps, and anything beyond that over current condition, circuit breaker trips off.
Okay. Hello? This is a prototype design, and a prototype design will cost more than when you're going to mass production. So we have a 3D design of our final meter. So what we have here, this is not the final look of our meter. So we sourced for this material locally. So then we did isometric drawing of our meter, which looks exactly like what we have here. So we actually spent more than what we were expecting. So now the question I want to quickly answer for this, trying to listen coming to yeah. As for the material, we don't have in Nigeria, we don't really have the sophisticated machines to make all these PCBs. This is a double-sided PCB. I make PCBs locally. Yes, I've been into this for like 15 years. I've done several projects for several companies and students in Nigeria. Like I said, Mantrack is one of the people I do stuff for, Wema Bank. So I work like as a freelancer. So we actually wanted to do this in locally, but we were looking at the cost. We are not going to contract the whole of the metering design to Chinese company because we also want to create job opportunity for Nigerians. So we need them to do some things for us. So when they send the PCB back, we actually couple the component on the PCB. We sent them this design, then we had to put the component on the PCB. So we are not contracting everything to the Chinese company. So with that, we were able to save cost. Like I said, it cost just $2.
I believe you wanted to answer his question.
Yes, you see, you have tried. What I'm saying is, obviously, is that if you send me your GABA file and DRAW file, that's what you send to the Chinese.
Yeah, we have the GABA file.
If you send me your GABA file and DRAW file, I will do the same PCB for you. I can do through plating machine, double-sided. I have the equipment. There's no problem about that. But nevertheless, I cannot start query your design here. I have equipment that can test whether it meets a particular class accuracy. If I stand up there, I'll be able to fault those things. But the concept, the fact that you have the entire architecture of how a meter can be designed is already a pass mark for you. Because you did not consider all those requirements, the country requirement, the global requirement in your design. You just choose a particular microcontroller that is ADC, and it has all the features specified.
The ADC is 13 bit.
Uh-huh.
The highest resolution we've worked with microchip at Mega, HAM, Cortex. So I worked with about 30 different microcontrollers before we decided to go for ESP32.
But there are so many, there's SOCs, there's AFE, there's so many microcontrollers you can use to achieve optimization of the requirement. But let's leave that one aside. The most important is that you have the good idea. Do you write your assembler language in you write your assembler
I write
language?
in about 20 different programming languages. We use C language to program
so
the
what
hardware.
do you,
then we use HTML, JavaScript.
And you now generate your X file.
For the back end.
You generate your X file.
Through the compiler. You write in C language, then use compiler to generate X file. X file is what you need to load into the chip to make it run.
Okay, fine.
We have that
those are things that is required by people like us that will be able to now take you through what the standard require for you to be able to produce the best meter in the country. But for the facilities and every other thing, the most hindrances that we have in the country today is the fact that there is a mismatch between component and products. The component, transistor, resistor, all those solid state components, you even pay higher tax, higher duty to bring them in than the complete component. Those are the mismatch we have. And that's why we're trying to straighten the entire process flow so that people like Samsung and every other thing can come to the country and set up. Once the component is zero, because component in electronics is like raw material. So once there is zero duty, then Samsung will come and set up their plant. They don't have choice. Thank you.
Thank you, Engineer Kola Balogun. I believe we're gradually becoming engineers, learning from you, because it's like a session here. Thank you for all the feedback, but we do have to, we can take questions so we can move. We still have 3 more presentations, so let's keep it to more of questions.
Okay, thank you very much, and well done to Team Tech Wizard. So I wanted to, I don't know if you mentioned it earlier, I'm interested to know the specificity of data that will be available on the customer UIU. I mean, how much, what's the granularity of the data that it can supply me when I'm trying to manage my entire household consumption? And then how much of that data, like for instance, you had a break in the SIM card transmission. So how much of that data can be spooled so that when service is restored, it's sending, so the time interval of transmission to the server, right? And, because of the wireless issues that we have, did you think of incorporating another communication channel? So say Ethernet, for those that have wired connections, is that something you think about, or would that increase the cost of that thing? Thank you.
Okay, I believe one of our judges had a hand up. Okay, so
thank you. I just thought I could always ask again. I actually, I know you mentioned something about the tamper, which is, something that the us in the value chain, which is the discos, are very concerned about. So I heard you mention something very briefly, but I think you just, breeze through it, because it would be really nice to know what are those features that you have really keyed into, for the tamper part of the meter, so that us at this end can, have great monitoring. Now, in part of that, what are the earthing, neutral earthing portions you've also put into that, into the meter, to ensure that even when the tampering happens, it's not the tampering that also causes any form of accidents, because when that happens, it's not exactly that the meter that will be blamed, but the organization that would actually have to bear that brunt. So I'm very concerned about that part as well. And then again, when there is that tampering, how easy is it with when you build in the entire meter? Is it able to have the accessibility and we can actually track and find out where that tampering occurred? It's very important.
Thank you, Ma. Do you want to try your mic if it works?
Okay, thank you very much. First to you, sir. You mentioned about data, the kind of data the customer can have access to. Sorry, if you can just try subscribe.cheated. That's the customer's dashboard. So you can just try it now. Subscribe.cheated.com. The same cheat that you used for Tech Wizard Meter. So you can see on the dashboard live readings of your real-time readings of your load in kilowatts, your consumption in kilowatt hour, your balance of kilowatt hour remaining. Are you there? Subscribe.
Subscribe.kethood.com. That's the URL for subscribers to remotely monitor their meters. Subscribe.kethood.com.
So you can try user TEST tester, capital letter T, then the password is A, H times, small letters. Password letter A, 8 times, small letters. So you see the also the you see also the power factor. We also have the power factor there. And one of the things that we also considered, seeing that we have a new service reflective tariff, is give them an idea of the total hour they have consumption for, just an idea of it. And so what a customer can do with this, and in a case where there's a problem with communication, the meter can still work locally, like I said. The communication doesn't affect the operation of the meter. Now, system is not coming on because we needed to recharge and demonstrate all that, and that unfortunately didn't happen. But then the customer can have his load reading. So should in case he wants to cut down consumption, and like my colleague mentioned earlier, you can remotely turn off your load from your dashboard. So you have that there also. So you have a remote control, yeah.
Okay.
And then for the tamper, right? Okay, so for the tamper, we have a tamper switch, and the tamper switch is located
inside. Okay.
It's located inside the meter, so it doesn't have an alarm, so as not to alarm whoever is trying to tamper with the meter. It just sends an email to the admin, and like I said, on the admin dashboard, all right, it has a section called meter tamper, where it shows a list of all meters that have been tampered with. So it makes it easy for the utility company to know how many meters or the meters that have been tampered with. And like I also mentioned, all our meters using our GSM module is the SIM 800 SL. So it has a inbuilt GPS functionality.
Track the location.
Meaning you can track the location. It logs the latitude and longitude of each meter. So far as we have, this is the GSM module here. This GSM module here. So it has incorporated the GPS functionality. All right. So the latitude and longitude is also logged in the dashboard. So when you see that tamper, you can just view it, and then you see the exact location, and then the patrol staffs can go and really handle the situation.
I believe that answers your question, Ma. All right. Thank you very much. A warm round of applause for Tech Wizard. So we'll use about 2-3 minutes for Tech Wizard to just clear up. There's going to be the next team coming out to present. So just to sort out all our sound, make sure that everyone can hear the presenting teams. And we want to use this opportunity for the judges to also start perhaps collating some of their scores, their results. If you want to excuse yourself to probably use the restroom, please go ahead, or to stretch, or to have some water, sweets, please do so. And yeah, for those of us that don't have judging duties, we can share our experiences so far. Let's do that on social media. Let's post things. Hope we're enjoying ourselves and learning a lot, right? Yeah, I think I've learned a thing or two. Like, technology isn't easy. Engineering is a whole lot of work, and engineer has been schooling us very well. So the next team in about 2-3 minutes will be here. They're just getting set up, wearing their microphones, and they'll be coming to present. We still have about 3 more teams, so I implore all the judges to keep our feedback at the minimum and keep it to questions, actual questions, so that it can help you in scoring each team. I believe one of the prizes the Honorable Commissioner mentioned had to do with mentoring. So even if they don't get it here, at some point they will get mentored and have their hands held throughout the process. But for now, let's try to focus on questions. So far we've had presentations from 2 hardware teams. The first, Power Bit Crunchers from Lagos, the Center of Excellence, and the second, who have just left the stage, Tech Wizard from Kaduna, the Center of Learning. And then our third hardware team that will be presenting is Gados Electrical here in Lagos. I believe they are being mic'd up as I speak, and they will soon be coming. So hopefully our judges can return. But the judges who are still here, I see, are fast at work collating all the scores. And I believe our judge here on Zoom, okay, his camera is off, but he'll join us again once we start. Okay, I can see Gados Electrical in the white shirts coming to set up. I believe in another 1 minute or so, we'll have to start. We're far spent for time. And like I mentioned earlier, please let's keep our feedback to questions. Questions that will enable you to score properly. So Gados, can you test your mics to just make sure? You can just say your name.
I'm Adewale.
Okay, and can we test your mic?
I'm Moses.
Say that again.
Moses.
Okay, can you?
Moses.
Yes, so I believe we'll need this external microphone. Please, our judges, our guests who have gone, please, I believe Mrs. Sholakwe Hammond, okay, I can see Engineer Kola Balogo, the Honorable Commissioner, just waiting so that we can start. Do let me know when you're ready to start. Okay. So I believe we're just waiting for one judge and the Honorable Commissioner, and then we can resume the presentations. As mentioned earlier, this is our third team, the hardware teams, and please let's focus on the hardware components. Tomorrow is for the software teams because you're being scored on hardware. Okay. Maybe in another minute or so, we'll have to start because we still have 3 more teams. Okay, I cite the Honorable Commissioner who is coming to take his seat, and then we just have 1 more judge. Okay, so before you start your presentation, let's know who you are, what you do, how you got into technology. Let's keep it short and sweet, and then you go right into your presentation. I'll be looking at time, 10 minutes for presentation. I'll stop you at 2 minutes as a warning, and then we'll open the floor for questions this time, questions, so we can go through all the presentations.
Okay, ladies and gentlemen, we are Gado's electrical team. Yeah, we are actually into embedded software system. So we come about this due to the drive of getting a problem solved. Because we believe that in Nigeria or in any world, there is no how we can go about it without having any issue solved. So we started Gado's Electrical 2015, and ever since then, we've been laying our hands on projects like having a smart smoke detector and the rest. We carry out a prototype, but we thank God for this particular opportunity that Lagos State has given to us, and we hope to do a greater things from this henceforth. Thank you.
Good afternoon, ladies and gentlemen. Please, we'll go straight to the hardware where we have here his smart meter. Our idea of smart meter at Gados is a meter that is almost like serverware. And it's a meter that should make life easy for both the user and the discos themselves. And that is our idea of a smart meter. And that's why we came up with this concept. Our smart meter is a meter that monitors users' energy usage, gives the report in real time to both the user and the disco, which I would be referring to here on after as the controller, the meter controller. So what this one does is that when we build this meter newly, like we made a design that can be both a prepaid meter or a postpaid meter. It depends on the configuration we set into it at when it's given to the customer. We felt like we can still have a postpaid meter that will still be smart and will still work as good as even a prepaid meter, even while we want something that would make it easier for customer to pay. So that's why we came about this concept. When this meter is being issued, the meter controller would select the options, the configurations they want for the meter, and set it into it. It might be prepaid. The configuration includes the energy limit, the tariff plan, the charge per unit, the meter number, the user number, the controller ID. All of them would be configured in the meter at the point of issuance. That's what we have here. So when the controller can monitor the meter at any point in time, because we have on the board, which I will still go through the components. I just want to talk about what it can do. On the smart meter here can monitor energy level. It can dictate, you can control the maximum energy limit for a particular user or for a group of users, like in a region. Let's assume there is a need for a load shedding in an area and you just want to put all the customers in that area on a limit, on an energy limit to balance the supply that you have. This is our concept. This is what this meter can do. You can send the message to them, to these meter from the software end. We already have a channel for that, which the software can send information into. We already have the pattern of the information that will be sent. And the meter would schedule all the meters in that area, or even it might be a single meter on the grid. It will set it to that energy level. If a user goes after, because the user also will be alerted that there is a need for energy scheduling and your limit is this kilowatt or so. And if a user goes beyond that limit, this meter will switch off, and the person would have to contact the meter controller to switch it on back. after confirming that he or she is reducing the load. So we have tamper switch there. As soon as anybody starts screwing trying to lose the screw, the switch there trips and send information in real time. What we have tried to do here is that every information on this meter you can get and receive in real time. You don't have to wait for it. It goes and comes. We use, there's a GSM module on board with the same. It sends, that's what we use to connect to the network, and it sends the data in real time. It sends from the guideline we have, it's supposed to be sending information back and forth every hour. But because of the testing purpose, we have made it sends information every minute. It will send information every minute so that for testing purpose, we can't be waiting 1 hour. So the user you can monitor any tampering, you can monitor energy limit, you can set, here you can send recharge to it. You can recharge in prepaid mode. You can send recharge like you connect to the way we recharge it to send the unit to this, and you will see immediately. You can, one of the other features we have on this meter is that it is bidirectional. So it monitors energy. The current sensor now, it's a bidirectional current sensor, which you can also use it to sense bypass, because if the bypass is not like it's a perfect condition, but it can also detect it. Like if there is a bypass of the live line and the neutral is still connected somehow to the meter will sense current in the line, neutral line, but there is no energy flow in the meter actually. So it will trigger the controller that there might be a bypass here. And that is a sign. It might actually not be a bypass, but it's worth checking, at least, apart from the tamper switch. So I will just go through the components we used. We used the ACS 758 all-effect current sensor for the current sensing. We have a GSM SIM800 for the GSM module. We use an Arduino Nano for the microcontroller. We have a ZMP 101B for the step-down transformer to monitor the voltage. And we have a real-time clock there to monitor the time ahead. The meter, because I told you that a smart meter, our idea of a smart meter is a meter that is self-aware. At the last day of every month, the meter automatically collects the information, the energy usage for the month, because it stores energy, the energy usage. It has a weekly storage. We have created units in the memory, in the EEPROM memory, that saves the energy in the unit. Like it saves energy usage per day, so you can know energy usage per day. It saves energy usage per week, and it saves monthly accumulated energy usage over the month for 7 months. So after 7 months, it overwrites the last 7 months, then it moves it back like that. So at the end of the month, the meter will send the bill to the users with the software, with the help of the software. It sends the bill to the user, maybe through mobile app, SMS. But here we have the channel where the bill will be, where the trigger will go to whichever way we want to send the SMS. And on the 14th day of the following month, the meter will check if, it will keep checking if the bill for the last month has been paid, because there is a memory section for unpaid bills. That memory section is unpaid bills. So if there is still any outstanding in the unpaid bills, the meter automatically shuts down on the 14th day of the new month. And that is how this one works. And in the prepaid mode, it works like normal prepaid. You recharge, it reduces your unit per the kilowatt hour you use, and when it's 0, it shuts down the system. And we also have an app to monitor that. We know that most of these other part of the device is the power work for the software, but we have designed our own app at least to monitor the work and how this operates, and that is what we have here. When we connect the meter at first, like our idea is that when you buy the meter, when you install, maybe when the controller has come to install your meter, it will still be off, it will be there until they ascertain that, okay, every documentation on the meter is done, then it will be switched on from their end and like that. So we will be testing
Gados Electrical, I hope the testing will be under 2 minutes
it
because
won't take
up
time.
to 2 minutes because your time is almost up and then we'll have to take questions. This time around, questions, just so we can manage our
So,
time.
Yeah, as we can see now, okay, no, plug this, just plug this there.
So we can use
The socket, plug it there. I thought it's the phone. I thought it's the fridge. I'm sorry for that. Sorry, I wanted to connect the load to it. So the meter is on now, but the switch connected to it is off because it's assuming that I just connect. I put it as I just connected to it. So from the app now, I can just switch it on at will when I want it on. So it's on now. So, and that's the same way the controller can switch on and off any meter across any grid at any time they like. So, and here I can also switch it off from here. It goes off like that. If we have a tamper switch, okay, let me put it on. Let's assume it's on. So try to lose that screw now.
Yeah, this is like a tamper switch.
It will send the information to the controller. Case opened. It's already on the app. So on the software side, there will just be a trigger that would have been created. This thing will trigger that part of the software, which will generate like an alert on their dashboard that a meter has been triggered. Then the ID of the meter has been sent. You know, I told you at issuance, we put all the configuration on the meter. So thank you very much. That is
Thank you
basically
very
everything.
much, Gados Electrical. One round of applause for them. They're our third team. So I said it's questions and answers. Let's try to minimize the feedback so we can get through the presentations. And I remember the Honorable Commissioner said one of the things they're going to be receiving is mentoring. So that'll be a time where they can be handheld through the process. I'm going to use my powers as the MC to favor the people who haven't asked questions. So there are two judges that haven't asked questions. Looking at both of them. Who wants to go first? Okay.
Thank you. So I think my question is more broadly around commercial. I think the technical guys are able to address the technical issues. It's really around how are you able to value and measure the components that are locally sourced and the inputs that are imported. What percentage is that in general? And I think this also applies to the other participants and the forthcoming ones as well. I think ultimately, the question around domestic production and your inputs and the foreign exchange impact on it is very critical. And one of the judges did highlight, you know, one of the policy around reducing input costs. But it would be good to hear from you if you've done that analysis and you can give us a figure, what percentage of your inputs are local and what percentage are imported.
Just before you answer, we'll get questions from another judge.
Thank you. So I'll just say well done, first of all, and let's go straight to the question. I think it's very important. So from a DISCO standpoint, I'm sure you know I work in the DISCO. So I'm looking for something here, and I want to know what your understanding around certification. So you want to come into a regulated environment. There are rules, around standards and specs. I like what you're doing. We want to encourage, but I want to understand. So you forgot to talk about cost also. So make sure you mention your cost because it is a competition. And then after cost, let's maybe understand what you know about at least trying to get your go-to-market in terms of whether your product can become a product that the public can use.
Thank you very much, sir. So I wrote down the questions.
Thank you very much.
So we'll start with the first set of questions, which looks at the components, how much of them are locally sourced or sourced for in terms of percentage.
Yes, thank you. All the components are locally sourced and they are even sourced here in Oshodi. Everything sourced locally, nothing imported, nothing. In fact, it was done during the lockdown, so actually, obviously, we couldn't import anything. And it is they're very cheap. We got it about all the components. We try to work towards meeting that margin, that cost margin that they gave us, and they are all sourced locally and cheap.
Okay, so the actual cost of it.
The actual cost of it is about 10,800 naira.
Naira.
Yes.
Okay, and then the question around certification, standardization.
Yes, we understand that as an electrical community, it's a regulated environment. You have different standards. So what we plan to do is, if we have a device, like all of that demo devices that we have, what we're trying to do is we read through the generally acceptable standards. We make sure that we try to try to modify all the projects to something that looks like the standard that they want. Then we can now present it for certification. And that is what we look to do. We actually want something standard that can be acceptable, not only here in Nigeria, that can be acceptable across Africa and even to the world. So we look forward to certifications.
And then the go-to-market strategy you have in mind?
Yes, we have our strategy, our marketing strategy in mind, and our marketing strategy is what we actually have here. All our very dignified people sitting here. We know, like me, I already have Mojek in mind from onset that as a map, I know that if we can make a meter that is good and we can be mentored to make something that looks perfect, that almost perfect or perfect, we can approach them. They can even guide us more because they have more experience. They are well known in the market, and we can also. So this is our plan. This is our marketing strategy. That the masses need meter, and we can provide. So that's our marketing strategy.
Okay. Okay.
Just one last question. Can I ask one quick question?
Since he mentioned Mojek, I thought maybe I might just ask a question right quick. Thank you so much. I think, you all are, I mean, like I said, I thought this was going to be short, but now I'm thinking I could stay here all day because everyone's presenting things that are of interest and applicable to the industry at the moment. So team, I think you're called Gados, right?
Gados Electrical.
Yeah. What I did not get from your presentation, and again, we could, be very thorough, right? I've opted not to because, again, time and the fact that we're going to have some time to do that later. There's some mentoring, to all of this, right? But obviously, we're talking about going to market, okay? And so it's good to know what the meter type is, right? So your communication, right? Type. And then also, are you, I notice I don't see you, is this new technology or you don't have to have one. I'm just interested in knowing whether your design today, right, includes a user interface or does not, include one, right? So what's your communication technology, right? And then lastly, tampering is one of the, what shall I say, energy theft particularly, is one of the major sources of revenue losses and one of the critical things that discos, and I'm sure that's what the MD was alluding to earlier, right, have to monitor today is lowering their ATC and C losses, right? Now, the way your meter is built, does it take into, does it take into account, right, changes in neutral and phases and things like that? I'm not sure I heard much about, I noticed you mentioned, just the removal of the cover, right? But Nigerians, some who don't want to pay large bills, have come up with amazing ways to tamper with a meter. So those are some of the considerations that really do need to go into this without necessarily even getting to the standardizations and the requirements. And as Jim Balogun mentioned earlier, there are several standards that's still going to be required for us to be able to meet, right? For this to be able to go to market. But again, just off the top of my head, those are things that I'm curious to know. And then lastly, how quickly do you dump data, right? So I noticed that you said it's remotely and online. How quickly can you extract this data? Thank you.
Thank you very much. I think that will be the last set of questions for Gados Electrical. So let's start with the meter type and the presence of a design user interface, if you have one.
we do not have any design and user interface for this, but he has, the meter is sending data in JSON format every minute, which ordinarily will be 1 hour in the real sense. So it's sending data. It's just like we have created a channel for software to grab their data. It sends data on the meter state, on the energy usage per hour, energy, the total cumulative energy, the bills, and everything. It's sending it every hour. Like if you check my phone, it's coming in on that. So that is about the
What about the meter type? The type of meter it is?
Yes. Our communication technology, it communicates on MQTT, message queue telemetry transport. That is, when we look at all the transport protocols that we have, we discovered that MQTT will be the best for a design like this because it is lightweight, it has small bandwidth, it really consumes data, even though data is sending data on devices like this on any channel is not really bulky. But MQTT makes it seamless, can communicate at will at any time. Either way, either party can initiate communication immediately, uplink and downlink MQTT.
What about the question on tampering?
Yes.
Yeah, I think we mentioned earlier that this smart meter is actually designed to handle tampering. And we have the tampering switch at the screw side.
No.
So if any customer attempts to do it, there will be a total blackout.
She then mentioned that about user misconfiguration of the line, the live and the neutral, and that is what we have actually looked into. This all effect sensor is bidirectional. There is no live or neutral. You can place it anyhow. It will still work the same way. So that is the advantage. There is no mixed polarity or either neutral phase. It takes the two, is bidirectional. Though there are some that are single directional, but this one is bidirectional.
Okay. Is that a question, sir? Okay, we can't take any feedback, just questions. So, yes, I think there was just one more question here, which had to do with the time of the communication of data.
That's what I said. Communication is instant. You can get it anywhere, anytime. Nobody has to initialize the communication because of the transport protocol. They are connected every time. It's always connected. You can pick and connect anytime.
Thank you very much. A warm round of applause for Gados Electrical from Lagos. Right now, we'll be having a penultimate group, the fourth group to present, and that will be okay. So we've extended the time. So please, let's keep the enthusiasm going because we still have two more teams. We have our judge online who would like to speak, and also Engineer Balogun, but very short so that we'll have time for the other team. So over to you, sir, Mr. Bumi Akiyemiju.
Okay, so
you can
sorry.
just unmute yourself and you can make your contribution, or is it a question?
Yes, it's a question, and it will be a very, very quick one, actually. Speaking of communication, I think beyond this problem around security and tampering, another very, very big challenge in Nigeria with smart metering is communication. Have you guys thought about maybe using dual SIMs or any other kind of mechanism that is practical? Because, in some cases, Airtel works, in other cases, MTN works, and communication, I think, is a fundamental challenge. So any ideas there? And then the last question is just, you have to think about innovation all the time. What's going to be drastically unique about your strategy? Thank you.
We have not considered dual SIM method. What we have considered is just, we have the onboard serial communication channel, which we can plug serial connector into and pull data to the system or to any device, and just the SIM. But now that you just gave us that idea, we will look into it. Obviously, now I have not seen dual SIM GSM sheet. I have not used that before, and we will try to look into that so that we have dual network, because it's actually true what you've mentioned. And on the other side of
Innovation.
the innovation, what will be different about this? What will be different about this is our concept of smart meter. We have a lot of, we really have a lot of ideas to put into smart metering. We want to make sure that smart meter is actually smart enough to know the things around it. Just like I told my friend before we came off stage, we want to be able to embed a lot of other sensors into our smart meter, like monitoring temperature, humidity, monitoring rain, and monitoring the temperature and humidity and every other conditions around, such that DISCos, GENCOs can actually go into the system, pull the data, what we call the big data, and actually be able to forecast or predict that what's the effect of rain on the electricity distribution in this area. Why is it that if there is rain, this area does not have light and all of that? They will be able to know that there was rain at this point, there was heat at this point, and all of that. We have a lot of ideas we want to embed into the system, and that is what we think would make ours better or different from others. And we still have order to add to it too. Thank you.
Thank you very much, and over to you, engineer. Yes, it should be on, sir. Sound, please.
Okay, hello. Quick one. Well done, Gados. And you just inform of enlightenment about what tampering is all about in the power sector, especially on the downstream. Energy accountability has been major challenges for the DISCO, right from the substation into the consumer premises. It is when you choose to unscrew meter that the meter will detect. What if I bypass before the meter? The meter is blind to it. So what we are trying to do is to build a synergy such that the entire downstream profiling of auditing from the substation, we want a substation meter that will be able to see the entire meter connected to that transformer. We'll be able to sum the accumulated energy consumed by each of the meter, minus it from the energy that gets out of the transformer, and be able to identify whether we have a big wide gap. In that case, physical foot must be on ground. We now inspect because there are smart ways of bypassing, besides the fact that they will tamper with the meter. There's a lot of logic we need to build into our applications because we are on the ground. Most of your concept is still very good. It shows how intelligent we are in terms of embedded world, but means appropriation of the knowledge is what we are facing, which we are going to guide you to make sure that this product is viable, is commercially used, and can meet the international standard. Because complying to various standard procedure in terms of certification, you will change the design entirely. So many, because there are so many certification process you need to pass through to be able to key in into what the DISCO is requiring for this. Those are the issues, but fantastic. You've gotten the idea. The embedded world is right here in Nigeria to stay, and we'll make it to grow. Thank you.
Thank you so
Thank you
much,
very much.
Engineer Kolabalogo. One round of applause for Gados Electrical. Thank you very much. We'll have our fourth team come to present. While they are setting up, we'll like the judges to use this time to collate their scores, to gather their thoughts together. And we have two more participating teams. So we'll try as much as possible to manage the time that we have. Thank you so much for your cooperation. Thank you so much for your
Are we now
feedback.
putting this down?
I'm sure.
That's our evidence.
Let's stretch and return to our seats very shortly. Our next team here is from Enugu, the coal city states. They're called Smart Energy. Before you go into your presentation, which you'll have 10 minutes, I'm going to be timing you. And when it gets to the 8th minute, I'll let you know you have 2 more minutes so that you can gather your thoughts and just wrap it all up. and we'll have time for questions and answers, which should be 10 minutes, but sometimes it extends a bit, so it might be 15 minutes. So 10 minutes for the presentation, but before you go into your presentation, would like to know who you are, your names, what you do, how you got into technology, short and sweet. So we'll start with you.
Okay. Good afternoon, all. I'm Ihere Michael by name, and also from Enugu State. Currently, I'm a software developer, precisely Java.
Okay.
My
and
name
you?
is Ume Emmanuel. I'm from Enugu State. And I'm also a software developer, core API developer, and also PHP Laravel developer. So in getting into tech, I found out that the life we're going to now is actually tech world. And for us to move forward, we need to grab that skill and change life. So that's actually what motivated me to go into tech world. And I'm happy that I'm in tech world, and I'm happy that I'm impacting in the society. Thank you.
Thank you. So I'll look at the time. You have 10 minutes for your presentation.
All right, thank you. Okay, let me quickly run through the circuit. First of all, this smart energy thing. So you have a voltage transformer for measuring the voltage, and also the current transformer for handling the current side of it. In our circuit, you have the ROTC, that's the real-time clock that handles the timing, because we are calculating energy. And you have also the power factor, that's the time lag between the voltage current and also current voltage for inductive and also for capacitive loads. So these we calculate our energy, and with our SIM module, SIM 800L, we send this data to the server. So this happens in real time. So the server collects this information, we send them through JSON format. The server collects this information, and also with the information from the server, we can, the utility personnel can monitor the load from a remote side. Take, for instance, we designed an Android app for this. Now, the utility personnel from the system can monitor the data sent to the server from this, and also we did it in such a way that a user can actually monitor his load. Monitoring your load in the sense that you might be using a lot. Let me say you have a heater, you have your AC turned on. It will help you to know how you're using your load and be able to control your load. It helps for load shading, so that you know how you're handling your bills as a user, and also the utility personnel will be able to monitor the load from the remote side. So these data we collect from the meters are not only for just monitoring. We also use them for, let me say, for to detect bypass. But before I go to bypass, let me talk about tampering. For tampering, we use contact method to handle tampering. But actually, we used contact method, but I thought about another means of handling tampering, like using ultrasonic means and also using infrared means. Those methods would be very, very okay. Because of time factor, I was able to use contact method. But in the near future, the contact method might rupture because this is where current passes. Now, for the bypass, this is exactly what we did in smart energy. Now, those data we collect, that's how we're going to handle bypass. Those data we collect, we mine. Now, we use it to plot graphs. Now, plotting the graphs of those data, we now train them. We introduce AI into this. We actually introduced AI into this. Now, those data, we collect the data of the faithful customers. We collect the data, and those unfaithful customers, we actually love them. We collect their own data. It will help us to know how to handle bypass. So when we train these data, now using AI, we'll be able to detect people that are really doing this bypass. Yes, we detect the people actually doing the bypass from the data we have trained. Now, for the Android app, let me quickly show the Android app. This is Android app. The person monitors his load. And furthermore, not only monitoring your load, you can actually, you can actually pay your prepaid this thing instead of using normal way of the normal way that's actually cumbersome for one to to do the transaction to payment, you actually do the payment from the app. This is your meter ID, your meter number, and you impute the amount. Once you impute the amount, you send it. Automatically, a token will be generated. So once that token is generated, automatically your meter is activated. Now for that tampering, once someone tampers with the meter, maybe opening the screw, it automatically trips off. Tripping off, the meter will still be open because it has internal battery. That battery system is just for it to continue working. So it sends data to the remote side, then that this meter has been tampered. Now you see it's tampered, is active, the voltage reading, current reading, power factor, real time, apparent power, reactive power, and energy reading. So this information, we collect them from the remote and without really visiting the gadget itself, the device itself. So this server, the reading we gotten from the server, yes, is being designed with API, Laravel, and PHP using JSON format. These data we collect from the remote end are again not only used for the AI. We also use it for monitoring, for load shedding, because most times you discover that the transformer trips off not really because there is no power at 3 kV and 11,000 kV, because overload at the transformer. So the bimetallic trips off. So these will also help for the consumer itself to monitor his load. So furthermore, let me talk about the data side of it, the EEPROM. So when there is no, we don't have enough network to transfer data, it has an embedded EEPROM. Those data are just small kilobytes. It stores those data internally, and whenever you have a stable network, it transfers them to the remote server. So basically, this is how the system works.
Well under time. Thank you very much. I didn't have to cue you in, so I'm sure we have questions for. Okay, would you like him to turn it or to display it better? You're also invited to come to the table to have a look. Okay, sir.
Smart energy, thank you. Okay. You are the only one that mentioned token generation. Your token generation was based on which protocol?
The protocol used for the token.
Or based on what standards?
All right, permit me to answer the question. The token generation is generated at the back end, in the sense that when you put the amount that you want to recharge, we already know that those things is for us to use to track each payment. And by tracking each payment, we connect through other payment gateways to collect the money. So once the money is collected, so those tokens are actually an ID for those payments.
Okay, don't worry, don't stress yourself. You see, token generations, there are open library. There are open library source for token generation protocol. But then in Nigeria, we have a specific line of path you need to take, such that because each disco, they are self-accounting disco. The token you generate for Eco Disco should not go into Ikeja Disco, and so on and so forth. So that is the reason why we keep laying emphasis on standard and procedure of designing. So those are the missing link in your conceptual design. You must first of all understand what is obtainable, where you want to use the meter. None of these meters that they have been presenting that you can go and plug into anybody's house. There are some query procedure I can carry out now. I know this meter will not pass. But that is not to say you don't have the entire scope of concept. You already have the embedded design. You use Arduino, right? For your display, right?
No, we use AtMega. We didn't use Arduino, we use AtMega.
Okay, so these are open pluggable ADC devices. So when you want to design, you look at what are the standards that I need to comply with. With Nigeria, we have metering code, IEC code is there, SCS code there. Before you can even get the certification for SCS, you have to go to South Africa. They have to query all those things. And you know, there are the hardware and the software. All of them must link. These are the procedures you need to pass through. You have tried very well. The concept knowledge is there. You know what to do. All you have to do is for us to guide you so that you'll be able to pass through the necessary procedures so that your meter will be a world-class standard and Nigeria will be able to use your meter. Thank you.
Thank you very much, sir. Do you have any questions?
I was wondering, did you mention the price of this meter?
Okay, sorry.
I think that's number one. And in terms of the communication channel, is it SIM? Can you use a wired connection, Wi-Fi, Bluetooth, any of those communication channels available? And in terms of storage, any storage capacity locally, or is just real-time transmission? Thank you.
Thank you, sir. So the price, communication channel.
Okay, thank you. Let me answer the question.
I believe your mic is working.
For the costing, everything costed, for a bill of materials, it costed us 11,000 naira for this particular gadget. Secondly, you made mention of whether it has, for our storage, the processor already has inbuilt EEPROM. It's already in kilobyte. This is what we use for storing in case there is no network. But actually, the memory is just minimal memory, kilobyte. We could actually extend the memory using external one. Let me say 32K. We have 64K. I've forgotten the chip. 24CO2, something like CO32K, something like that. That handles the memory side of it. Sorry, the last question.
It has to do with the communication channel.
Okay, communication. Aside from, we have SIM module. Aside from the SIM module, we also made available the USB port for the communication. So I wrote a Java program on system. I wrote a Java program. That Java program uses COM port. So once I attach my USB port on system, it automatically collects all the data from the server through this on my system.
So is it in real time? Is this stored?
It is actually the data stored on the server real time.
Does that answer your question, sir? Thank you.
But I don't think you indicated whether you have a UIU or you don't need a UIU. I know you mentioned your Android.
Okay, I did a UI.
Is this the one that has the AI built in, or am I mixing it up? And then secondly is interoperability. Are you familiar with that concept, interoperability? In other words, would your meter need to only speak to your head-end system, or can it speak to any head-end system? And I think the language that you use and some of the industry specifications that he mentioned is part of what would enable that, right? But it would be good to get an answer, right, to know whether or not your meter is interoperable, right? And I believe you said it's IoT based.
Exactly.
The entire design is IoT based. Okay. Does he have a PCB inside?
PCB.
Right. So meaning your PCB, did you what kind of design is it? Is it circuit?
It's actually not designed. The PCB, we did a normal, but we designed it on using Pro Tools. Let's say.
Using what?
Pro Tools.
Pro Tools. Oh wow. Okay. All right. So those are my questions. Thank you.
I want to answer her question.
Okay.
Interoperability. Aside from the utility personnel getting your data from the remote end, we did a design in such a way that even you as a consumer will be able to monitor your own load. I gave an instance where maybe you traveled, something like that. Your children in the house, maybe on something like your AC, your hot plate, all those stuff that consumes high watts. From the Android app, I did a notification, but whenever they stop, it has not beeped. I did a notification whenever it passes a particular amperage that you receive a notification. So you can just receive a notification and be sure, what is happening? Hello, please off that AC in the house, off this in the house, in order for you to save your time and something like that, and your cost spending. Thank you.
I know the essay asked about the cost, but I didn't hear a response. And I was wondering if you could demonstrate for us the tamper-proof.
I believe you said 11,000, right?
Yes, we said 11,000.
I said 11.
Thank you.
Okay. Okay. It's very shaky. It's not. So we've left the battery since on. It has been on since even when we are outside. So we have been affected now with.
Oh, no, it's fine. It's fine if you want. It's okay.
Well, I just want to demonstrate the time.
Okay, that's okay. Let me just ask you my last question. So how friendly is your user interface? So as a customer, if I want to see how much power I've been using over time and things like that, what kind of analysis can I do on your application? What kind of information does it provide for me? Thanks.
Just for the purpose of this gathering, I just like to give us a little bit enlightenment about cost consideration when it comes to metering. There are about 5 classes of metering in the sector today. We have 0.2, 0.5, class 1, class 2, and so on, about class 3. These are part of the component requirement in terms of selecting your component, because the sensitivity of the component is proportionate to how sensitive you want your meter to be in terms of accuracy. You want your meter in the house to read perfectly such that there won't be difference between what you are consuming and what is being read. There's a lot of things that put into consideration. Your heating in the house, in terms of how compliant your house is well grounded to the ground. Otherwise, you'll be paying higher rate, and your meter will not be able to even measure it at times. So in considering cost, these are things you have to. Most of these meter might not even pass class 3 in terms of accuracy class. But in the grid, we use class 0.2 because of the transmission losses and the sensitivity of the value of energy we are conveying. In the house, we use class 1 or class 2, as the case may be. These are part of the consideration of the cost when you are coming to the design. This guy, they have done a very good job in terms of understanding the procedure, the basic knowledge about meter design. But there's still a lot to be done in terms of educating them of compliance. So within their limits, they have tried, because it is difficult for you to tell Coca-Cola to come and compete in a beverage competition, because they know they know what it's all about. So this is what they can actually obtain, this kind of competition. They have tried very well, and all those things they have in mind can be brightened up by liaising with us in the industry so that we tell them how to make their meter perfect. So what Lagos State government is doing is the best. We have discovered that we have so much knowledge. I can even add more price to the price given to some of them by the time we finish the evaluation. That I will do. However, in getting this thing, okay, I will add additional 1 million to the price. In considering all this design, there are so many value addition we need to see that in terms of conceptualizing the entire thing so that some of the components can be produced locally in terms of harmonizing all these things. These are things we can encourage the young boys to do on their own. These are things we are going to do at the end of this session so that we can take the best of them and put them on the track so that they can produce product for the country. Thank you.
Thank you very much, sir. So another warm round of applause for our penultimate team, Smart Energy from Enugu State. So as we're waiting for our final. I think we can add to the prize money to get it to 15 million, 20 million. So right now we'll be having our final team come to present. So thank you very much. Well done. I know even just being here and receiving all the feedback from engineer Kola Balogun, I mean, I'm not a physics student, but I feel like I've learned so much. How much more? They're like, oh, I didn't think about it, but now that you mentioned it, I will definitely do that. Thank you so much to all our judges. Just one more team coming up to present, and they're also from Enugu State. I just love how the whole of Nigeria is represented here today. I mean, you have Kaduna, Lagos, Enugu, and I can just imagine the teams we'll see tomorrow. So here we have Cosmos Automation. Just before you start your presentation, which you'll have 10 minutes, and then you have questions and answers for 10, 15 minutes, would like you to introduce yourself. But before you do that, let's give Cosmos Automation a warm round of applause. So introduce yourself, let us know what you do, how you got into technology, and then 10 minutes for the presentation.
Good afternoon, everybody. My name is Abaraji Promise. I'm the CTO of Cosmos Automation, and that's my friend.
Augustine Wafo.
Yeah, he's
colleague.
Yeah. So Cosmos Automation is our dream to bring technology in Nigeria here. We are into automation. Our first product is called Yamere, and an IoT irrigation system. Yes, we used it in Enugu State competition, hackathon competition last week. So, and we had another product that is being produced. We want to make Nigerians to use inverter. So we made it cheaper for them. So we built a small inverter box that we want to be selling at the rate of 50,000 naira for every Nigerian. So that's our second product. So now, how we got into technology, we graduated from University of Nigeria, Nsukka. So we are classmates and we love technology. I want to take it to an extent that we want to start producing here in Nigeria. So we are enthusiasts and want to take it professional. So here is our meter. When you talk about meter, you talk about standards. When I saw the competition, I asked myself, when I saw the list, things they listed about meter and the standards in meter, as engineers, I asked myself, what are the standard multimeter? What is the meter I will build here that can be used in America? What meter I'll build here that will be used in South Africa? The meter I'll build here that will be used in every other part of the world. So in meter standards, there's language and metering system, which is called DLMS. So this DLMS concept is the language in meters, energy meters. So we sat down, though we saw this late, 2 weeks, but we sat down with our friends online to sit down. We worked more on the programming of this system to work on DLMS objects, the interfacing. We just did the first and the second level. And we now talked about the IoT part of the job. The IoT part of the job is when we use MQTT, so that every other person that is using, every other system that is working on IoT can be able to easily connect to it. MQTT is the most standard way of running IoT. That is machine telemetry query transport. So that's what is being used. Then under the DLMS, we divided it into two. We have the one that works, there is a server system that have two means of access. Our access is of two. We have the non-authentication and the high authentication. The authentication is when you want to access it through these optical ports. That is when you have to use password. But when we are the one we are running through our MQTT dashboard, our MQTT system, we are running it on non-authentication. So where in the non-authentication system, you just, MQTT is very secured. You use key on it. So we don't need to put authentication on the system again to weigh down our speed, our processing speed. So we just left the second access on non-authentication so that our MQTT system our IoT system can easily access it. Okay. So now, based on this meter, we launched it on an MQTT cloud. We are not the owners, it's owned by Adafruit. We launched it there to test it, to know if our system met an MQTT standard. And as we are talking now, it's working on Adafruit and Adafruit MQTT IO. And that means that it met the standard of MQTT and it can work as a server system. We used somebody's DLMS access system to test it. This guy, he's from India, so he gave us a software on DLMS, on his DLMS client systems. So we used it to test the system if it can access DLMS via Syria, which is RxTX. So, and we found out that our system can actually authenticate in these two ways. We have high and the non-authentication systems. So apart from that, energy meter, normally, as we know it, has one thing in common: monitoring of energy. So when we now, apart from the standards, the monitoring of energy system now have to deal with your current reading, your voltage reading. So we used current transformers of the ratio 2,500 by 1. So, and we use an ADC, ADS 115, which is a 16-bit ADC to measure our current and voltage. So separating it from the ADS of our chip, the chip we use, actually we sourced a chip. We have used a chip, a Texas Instrument chip, but when we saw this, it was for it to come from outside the country to this place, I think the competition would have ended. So we decided to use a chip in the market that we saw that at least, because we wanted to use ESP32, but it was unstable with the system to work with our ROF. We have ROF system here for our CTS. And so our ESP can't work with the ROF, so because the SPI has issues. So we now decided to use an ARM chip, which is Atmega 2560. So that's what we used. So, and this chip, in this system, we had battery inside. So why we built this system this way is that people can't tamper on it. Like when we brought it here, see, it was beeping to show that it's online, constantly online. So that nobody will say, okay, there's no light, let me go and do something. Let me go and do a magic. So once there is no light, the system is on 24 hours and it updates on our server every 1 hour. So if you do any tamper, immediately we'll see it here on the dashboard. And if you make payment, we will see it here from the payment. Now, I think we have two tamper systems. We have tamper here and tamper at the terminals. So you will remove the terminal now so that you've heard it, just on removing it. You see now our dashboard is now red and the system is off. Let me bring out this, my light bulb. So, yeah. So that's the light bulb for us to see it. So once you tamper, anywhere you are, once there's light or no light, our system has 4,4096 addressable EEPROM. So it can save, and each address saves 100,000 times. So these are about up to more than 15 years memory usage. So if you not say that maybe there's no light, you want to tamper, you should try it. So when you try it, immediately our system will notice it. And now this guy have been cut off. So before you tell us to put him back, you have to explain to us what he's doing on the meter. Because even on loading the CTS token or anything, you don't go to the meter. We have a separate CTS token loader that is here working with ROF that you can easily put your token here and the meter will immediately receive it. And on this CTS token, this system is sending the date, time, and units that is remaining instantaneously. So you will not tell us that, okay, I went to there to see my date and time, and this is logging to MQTT, and anybody that is running any software system or software platform can easily take any variable from this our MQTT dash and put it in their software. If you want to run admin, you can run admin. But what we have here is we want to run the standard that anybody that want to use anything you want to use, you can easily use it. So before I continue more to talk about this, I'd like my colleague to talk about the bypass systems. Thank you.
Okay, so for the bypass, we notice that people usually bypass their meters in different ways. The first one is by cutting the wire and connecting it to the earth. Now, what we did was that we used two current transformers, one on the live and one on the neutral. So even if you bypass, we'll detect it from here because there'll be current disparity. Then people also bypass by putting magnets to block the current transformer from measuring accurately. So for that one, we made a provision to put a magnetic shield over it, but we couldn't get out on time. But we made a provision to put a magnetic shield. But then in final product design, there'll be a magnetic shield over it that will make sure that even if you place a magnet on top, you won't be able to bypass.
Information, you have about 2 minutes, so I believe you can just round things up so we can take questions.
People also bypass by reversing polarity. Now, our current transformers can measure reverse current. Other than that, we also use the absolute value. So even if you reverse polarity, we use the absolute value and then we'll measure your unit correctly. Then for the bigger system, because each meter has a meter number, and meter number will tag with the location. Now, if we are supplying this location and they all have their meters and they're all logging if they're powered on or they're powered off, so they're all logging the power state. Now, if your meter hasn't logged for a while and all these other meters in the same area has been logging that they've been bringing and taking the light, then we know that something is wrong somewhere. So that's also another way we can detect that bypass. Then we'll also make payments. Okay, now if you look at this, the LCD is turned off. That's because we're in battery saver mode. But it enters battery saver mode when there's no load connected, you are cut off. That's maybe you tampered or you bypassed, you are cut off, or there's no light. So if there's no light, or there's no load connected, or you bypassed, or they are cut off for any reason, it enters the battery saver mode, so it saves battery. So now, it is red here because it has detected breach. So we'll first reset it from here.
So that's the red. So you can reset it from here. So once we reset it from here, okay. That is, we'll press the reset. This is the Adafruit MQTT dash. Is it not showing? Okay, that's the Adafruit MQTT dash. So you have seen this is the breach. That time we removed it, it showed breach. And this is the power status that shows that the power status is off. And this is the power state. So once we reset, so this is a GPRS to take a little while.
We'll give an opportunity for our judges to start asking questions, and perhaps the GPRS will actually cooperate. But a warm round of applause for Cosmos Automation. Well done, well done. Thank you very much. So, we'll open the floor for questions.
You know, Cosmos, I think I would like to try and almost be the defender of the other people that came before you. So you have a benefit. That is that I call it the benefit of the last presenter. You got a good sense, and it's not a bad thing, it's a good thing. It means that you listened a lot and you got a good sense of going straight to the issues that are the hearts of the judges and everybody else. And a good job by doing that. However, there's also something important about price. I was very curious for you to get to the point where you can talk about the cost of production of what you did. And make it interactive. You don't have to wait till I finish. You can yell out the number. Whether it was 15,000, 25,000, you can state it, just say it. So price being an issue. And then apart from that, I also don't want to take away from the raw, the whole local raw content of your presentation. It comes off a bit like you're the front room of a like a Mojek or Moma's doing already gone very far. We don't need you to present something that is very, or I don't, let me speak for myself. I want to see, I'm enjoying that UNN, that completed part of your stuff. Don't tell me about the other. I meet a lot of meter manufacturers every time, but I want you to just show me your production. So let's hear about just your view on that and your cost of production.
Okay. This meter, everything we have here is sourced outside, the chips and everything. So our cost of production here is up to 12,000 naira. Cost of production because they are sourced outside. But when we now go into major production, this is just producing a prototype which is more costly than going for major production. We sourced on the major production. We saw that each of these meter can cost like 8,000 with the CTS. Yes. Is that a UI? Yeah, this is the token loader. Yes. And you can view it here that if it sends the time, you can view it here. That's the unit in the meter. You can see it. It receives real time from this guy. And we have tokens here that we just generated from ourselves using parity bit and other things. That if we enter the token, the meter will receive it. Like let's just run that one as an example for you guys so that you can see it. And Austin,
yeah,
let's just come hold this. Let me.
This one is
Okay. So this is 1, 2, 9, 1, 4, 7, 2, 8, 6, 9, 6, 3, 5, 4, 2, 4, 4, 1, 0. Okay, 0, 9. Yeah. See, processing value token recharged successfully. So this is 9.0. So now when we type this system now to show that it have received the token. Have you seen that?
Yeah.
From this. Okay. So
it's having some issues, but once it comes online, it will immediately show here that I received
the token. That's why we produce.
And if you try to load that same token again, try it again.
Okay, if we try to load this token again that we have done before, to tell you that this token have been used before. So this also has memory that it saves that you've used this token before, and is able to tell you that you've used it before.
So
Honestly,
have
I part of the question was asked earlier, but I just wanted to commend you guys, Cosmos. I think this is probably the most detailed I've seen in all the presentations, taking into account core, items that manufacturers would actually be looking at, right? As well as probably the most close to going to market, right? So I must really commend you, and very well thought out as well. I would just want to ask you whether your design, because I noticed you have IoT, which is MQTT, you have a UIU. So can you use the design without a UIU also? In other words, your dashboard, can it what? Could you create one for the user without having to use a UIU, right? So in terms of when we're looking at cost considerations, right? These are some of the things that we will all be looking at, right? Eliminating just the use of the UIU. But if I could put some money, behind this, I will be putting, okay, am I allowed to say this? Yes, you are. I will be putting my money behind Cosmos Automation, and Engineer Balogun, I don't know if you want to start a bidding war, but I would be starting at $50,000.
Thank you, Chantel. Cosmos, you are, at least from my criteria of evaluation, you are the best for now in my own assessment, because you really go into the entire simulation of what meter-based input and outputs are. You have two, this is a single phase. You have two live and neutral in, live and neutral out. And you equally have UIU. You said you use RF for communication, and you are so sensitive about standard from your presentation. The first thing you mentioned is standard, and that's what you need to do. Cosine DLMS is a unit of a network interoperability for meter to be able to talk to one another. But on the downside of it, there are some other standards that you're supposed to have considered. I will have carry on a query on your meter now, the DLMS query on it, if it's going to pass. Otherwise, if it pass the query, if you are sure that if I send, come there and send you the query command and it will pass, then you win the best of price. If you are sure of that, but if you are not sure, let's leave it at that level. However, you are the best in terms of understanding what the industry requires. What you now need to do to further your knowledge and your design techniques is to study all the various books of standard. Try to join IEC to study all their white, blue, and white book, all the three books. You understand it so that you'll be able to comply to it. Then study metering code for NEC. Inside the NEC website, you will see metering code standard. Then there is communication protocol standard too. You conceptualize all those things so that you can improve. Like what Chantel have said, if I want to put my money on anybody, it's on you that I'm going to put my money on. When done, you have tried so much, and we will do further evaluation because we need to be able to test how you design your board. Do you design your board yourself? Do you send the board for PCB design? So if you don't design your board, then you need to know more about embedded design so that you'll be able to design your PCB board at any point in time. So we can make the PCB for you at any point in time if you can design. Well done very much. Thank you.
Thank you very much.
Do we have any more questions? I know we're fast spent for time, but at this point, I'm sure I can squeeze in an additional question, or maybe perhaps online. Okay, I can't see.
So I'll just congratulate the team for good work. Very professionally presented and technically, I think, sound as well. You did talk about your your inputs being mainly imported at this stage.
Yeah.
But you said when you go into production, you're able to reduce your cost.
Yes.
How much of that do you reckon you could produce locally?
Okay, based on this, from what the questions that were asked, this system is a dual system. It takes in, payments from here, and via our MQTT systems, you can also receive payments from there. MQTT is a standard protocol that anybody that is building any UI, anybody that's building any site, once you incorporate it, all you just need is our key, the key for the meter. Once you get the key for the meter, you can send any information to it encrypted via MQTT. So based on our circuit, we built our circuit house. In fact, we used, because of the time we spent on the code, we have to use a Vero board to solder ourselves raw. You can see it, you can see the battery inside, the charging circuits inside, nothing went to China. Okay, so based on the cost of this, you got this chip we used is a module. The cost for per chip should be like 1,000 naira, but because this chip is on its own, is not in Nigeria, so we have to buy it in a module. So the cost of the module itself is 7,000 naira. You can see the cost difference. So that is what made this to rise. Most of this mount. So the chip itself should be like 500, but because of the chip is not here, you can only buy it in a module. So we bought the module. This module, we have to remove some things from the module for us to use it to work. So this module sold 1,800 naira. So these are the costs that we are having because these things are not here. You buy them in a module and not in chip. Even the GSM module we use here is also in a module. You can't get SIM 900 or SIM 800, or even the 3G. Even a 3G is sold 35,000 in a module, 35,000 naira. So you are seeing the costs, all these things that are coming up there. When you want to do some of these prototypes, we don't have it here. We just buy the modules and put them together and you have it work. So that is it. But if we are to do more normal manufacturing, yeah, we can just get the chips, design the circuit. We do our design on Ego. So Ego and Easy EDA. So we can just design them and mass produce them, and it will be way cheaper. Thank you.
Thank you very much. A warm round of applause for Cosmos Automation. So at this point, the judges would like all our judges to move upstairs for a quick deliberation. I know some people have already let the cat out of the bag, but you'll still have to come together. Maybe it'll be a unanimous decision, or maybe you'll have to. Okay, their cat is out of the bag, but so they're all going to go upstairs to deliberate, and yes, so be. A long morning, a long afternoon, and some of us are having to go back to our various destinations. This is a 3-day event. Today is day one, if you remembered. It's all about hardware. Tomorrow is about software, but we're not coming back here. We're going to the head office, Access Bank PLC in Victoria Island for 10 a.m. And then we'll also have day 3 coming back here. But I believe Mrs. Doja Ikeriche, Advisory Board Member, Eco Innovation Center, will be addressing us before we close today's event. Thank you so much. Please can we put our hands together for Mrs. Ikeriche.
Good afternoon, ladies and gentlemen, and we are really pleased, and we can only just say thank you. We thank you, HC, Honorable Commissioner, for Ministry of Energy and Mineral Resources. This has been your brain work, and this has been your baby, your commitment, your vision to transform power distribution within Lagos State is much appreciated. And the next today and into the next 2 days are going to be indeed history making within our state, and we all are committed to that. We want to thank significantly the entire team of the HC from the Ministry of Energy and Mineral Resources. We also thank the entire team of Eco-Innovation Center for the hard work, tireless, to put together this multi-stakeholder, in fact, international kind of program. And the hard work Uju in particular and Michelle have put into this is remarkable, and we say thank you. We're looking forward to the rest of the 2 days to be just as fantastic. A big, big thanks to our judges, captains of industry. You have left all of your busy schedules and calendars to come and make this commitment. It's indeed a reflection of the power of partnerships and how we work within Lagos State to indeed make the state a 21st century state. Might I also acknowledge the entire cabinet members of Lagos State? We thank you for your commitment as well and your encouragement all through this process. Now, I want to thank the media, and we encourage, please, the highest level of amplification globally, because we want the world to know that we are delivering domestic solutions, Lagos solutions for
and the engagement was excellent. I know all the participants have learned so much and really enjoyed your support. So thank you very much to everyone. We hope to see everyone tomorrow at 10 a.m. Access Bank PLC, their head office in Victoria Island. And the pictures and videos you've been taking, now is a good time to share them on social media. Can we have the aides of the judges come? I believe we want to have a group picture, and can we just congregate here? So the aides of the judges. So the paparazzi, you'll still have your chance to capture all the beautiful moments when the judges return from their deliberation. I know you're particular about the backdrop. So as we're leaving, please let's share all the footage and comments and feedback. Like Mrs. Ekeruche said, it's not just going to Twitter to complain, but also being a part of the solution. So please let's have our feedback shared.
Victoria Island. I see Lagos, where the Okada man is returned to his tailor shop, where the shoemaker is happy doing his job, and our programmers can code 247. I see Lagos, where our children can learn under a more conducive atmosphere. I see Lagos, where everything is connected and the city shouts for joy because the light has come. I see Lagos, where the economy flourishes because of better electric supply, where the people are happy with their government and government happy with the people. The Lagos State Government, through Ministry of Energy and Mineral Resources, is partnering a co-innovation center to facilitate meter design hackathon that will develop an affordable and smart metering system, leveraging local talent. 7 million naira to be won by the winning teams. We are calling all Lagosians to come watch the hackathon live from Wednesday 16th to Friday 18th of September 2020 as we pick the final winning teams. Register via this link to be part of the event: www.lagossmartmeter.com/event/sponsors. I see Lagos, where electricity flows from Bariga to Badagry, and Agege melts into Victoria Island. I see Lagos, where the Okadaman is returned to his tailor shop, where the shoemaker is happy doing his job, and our programmers can code 247. I see Lagos, where our children can learn under a more conducive atmosphere. I see Lagos, where everything is connected and the city shouts for joy because the light has come. I see Lagos, where the economy flourishes because of better electric supply, where the people are happy with their government and government happy with the people. The Lagos State Government, through Ministry of Energy and Mineral Resources, is partnering a co that will develop an affordable and smart metering system, leveraging local talent. 7 million naira to be won by the winning teams. We are calling all Lagosians to come watch the hackathon live from Wednesday 16th to Friday 18th of September 2020 as we pick the final winning teams. Register via this link to be part of the event: www.lagossmartmeter.com/event/sponsors.